Welcome to the Cloud Computing Bootcamp. In this bootcamp, you will embark on a comprehensive journey to learn about cloud computing, one of the most transformative technologies of our time. And also, you will gain the knowledge and skills necessary to navigate the world of cloud computing with confidence. Did you know that the value of the cloud computing market was $370 billion in 2020 and estimated to be $830 billion by the end of 2025? Due to this, the market value has set up a high for data engineers. An average salary of a data engineer is $114,000 in the US and 8 lakh in India. Throughout this bootcamp, you will learn what is cloud computing and its fundamentals. Moving forward, we will learn about virtualization. Next, we will understand what AWS is and its services. Followed by, we will go through Azure and its services. Next, we will learn some difference between AWS and Azure. And at last, we will learn about how to become a cloud computing engineer. Now, over to our training experts.
Imagine you're the owner of a small software development firm and you want to scale your business up. However, a small team size, the unpredictability of demand, and limited resources are roadblocks for this expansion. That's when you hear about cloud computing. But before investing money into it, you decide to draw up the differences between on-premise and cloud-based computing to make a better decision. When it comes to scalability, you pay more for an on-premise setup and get lesser options too. Once you've scaled up, it is difficult to scale down and often leads to heavy losses in terms of infrastructure and maintenance costs. Cloud computing, on the other hand, allows you to pay only for how much you use, with much easier and faster provisions for scaling up or down. Next, let's talk about server storage. On-premise systems need a lot of space for their servers, notwithstanding the power and maintenance hassles that come with them. On the other hand, cloud computing solutions are offered by cloud service providers who manage and maintain the servers, saving you both money and space. Then we have data security. On-premise systems offer less data security, thanks to a complicated combination of physical and traditional IT security measures, whereas cloud computing systems offer much better security and lets you avoid having to constantly monitor and manage security protocols. In the event that a data loss does occur, the chance for data recovery with on-premise setups are very small. In contrast, cloud computing systems have robust disaster recovery measures in place to ensure faster and easier data recovery. Finally, we have maintenance. On-premises systems also require additional teams for hardware and software maintenance, loading up the costs by a considerable degree. Cloud computing systems, on the other hand, are maintained by the cloud service providers, reducing your costs and resource allocation substantially. So now, thinking that cloud computing is a better option, you decide to take a closer look at what exactly cloud computing is. Cloud computing refers to the delivery of on-demand computing services over the internet on a pay-as-you-go basis. In simpler words, rather than managing files and services on a local storage device, you'll be doing the same over the internet in a cost-efficient manner. Cloud computing has two types of models: deployment model and service model. There are three types of deployment models: public, private, and hybrid cloud. Imagine you're traveling to work. You've got three options to choose from. One, you have buses, which represent public clouds. In this case, the cloud infrastructure is available to the public over the internet. These are owned by cloud service providers. Two, then you have the option of using your own car. This represents the private cloud. With the private cloud, the cloud infrastructure is exclusively operated by a single organization. This can be managed by the organization or a third party. And finally, you have the option to hail a cab. This represents the hybrid cloud. A hybrid cloud is a combination of the functionalities of both public and private clouds. Next, let's have a look at the service models. There are three major service models available: IaaS, PaaS, and SaaS. Compared to on-premise models, where you'll need to manage and maintain every component, including applications, data, virtualization, and middleware, cloud computing service models are hassle-free. IaaS refers to infrastructure as a service. It is a cloud service model where users get access to basic computing infrastructure. They are commonly used by IT administrators. If your organization requires resources like storage or virtual machines, IaaS is the model for you. You only have to manage the data, runtime, middleware, applications, and the OS, while the rest is handled by the cloud providers. Next, we have PaaS. PaaS, or Platform as a Service, provides cloud platforms and runtime environments for developing, testing, and managing applications. This service model enables users to deploy applications without the need to acquire, manage, and maintain the related architecture. If your organization is in need of a platform for creating software applications, PaaS is the model for you. PaaS only requires you to handle the applications and the data. The rest of the components like runtime, middleware, operating systems, servers, storage, and others are handled by the cloud service providers. And finally, we have SaaS. SaaS, or Software as a Service, involves cloud services for hosting and managing your software applications. Software and hardware requirements are satisfied by the vendors, so you don't have to manage any of those aspects of the solution. If you'd rather not worry about the hassles of owning any IT equipment, the SaaS model would be the one to go with. With SaaS, the cloud service provider handles all components of the solution required by the organization.
A multi-platform cloud architect and trainer working for Simplilearn. Let's dive deep into the topics we're going to discuss here. Why we needed cloud computing to begin with, and what is cloud computing and different types of cloud computings available at the moment. And we also are going to talk about dominant cloud providers available in the market at the moment. And we will touch a few topics or scenarios on life cycle of a cloud computing solution. And we will be talking about how cloud computing is implemented in AWS. And there's nothing like visually seeing how things work in the cloud, right? So we're going to end it with a demo, and we're going to talk about products, or we're actually going to use products like EC2 and S3. EC2 being a virtual computer in the cloud, and S3 being an object storage in the cloud. Let's understand about why cloud computing was needed. What was the problem that we had that cloud computing solved, and since then it took over the market. Let's understand that first, and that will solve a lot of unanswered questions about cloud computing or services that you might have. Here on the left, we have an owner of a business, and he wants to set up an DC or have an IT infrastructure for his company. So he called Paul, an IT educated person in his company, and consulted him about how to go about setting up an IT infrastructure. Now, Paul is the kind of guy who keeps himself updated about what's happening in the IT industry, and he frequently goes through learnings about the recent technology. So without missing a beat, Paul suggested, why not set up the environment in the cloud? But his manager was not sure about what is cloud, and more than trying to understand what cloud is, he was curious about the benefits of cloud over having an DC locally. So Paul started to explain the very same thing I'm going to explain to you now. Let's start with the expenditure or the billing model. With cloud, the billing model is pay as you go type, meaning we use less and pay less, and we use more and we pay less per unit. On the other hand, in on-premises, we can't expect that. We pay everything upfront, and there is an additional operating cost, and it never lets us to dynamically scale. In on-premises, a lot of space is required for seating the servers, but in the cloud, not such space requirement is needed for the organization. In on-premises, we also need a dedicated team to manage the hardware and software, but in the cloud, no such dedicated team is needed for most of the services. They all get managed by the provider, and even if we need to manage them, the provider gives us options to manage them through the console, which is lot simpler than managing directly from the device. In the on-premises, we need to admit the fact that data security is poor due to the cost involved in procuring the hardware and software to provide the security. But in the cloud, the security standards are high due to the investments the providers have done to secure the data and to meet the compliance. In traditional DC, there will generally be less focus on data recovery, and we kind of settle for less when it comes to data recovery due to the cost involved and the effort involved in replicating the data. And even if we set up a high performing data replication, a lot more can be done in the cloud for the same cost. The on-premises environment lacks the flexibility needed today. Like if I need to restructure the IT for the new age business needs, then the on-premises is not so friendly for such changes. But in the cloud, I can easily undo or tear down an environment or migrate to the new environment and tear down the old environment in few button clicks. Now, looking at the number and the frequency of the releases that happen, scheduling updates would be a full-time job. But with cloud, the updates happen automatically. In on-premises, if I'm working with a team that is spread across the globe, working with them in unison and sharing the data is a tedious work. But with the cloud, there are a lot of tools and technologies put together that makes it easy to share the data with other members in the team or with the new prospective customer. In on-premises, if I'm working with a team that is spread across the globe, working with them in unison and sharing the data is a tedious work. But with the cloud, there are a lot of tools and technologies put together that makes it easy to share the data with other members in the team or with a new prospect customer I will be working with who is present across the other side of the globe. In on-premises, the data will be present inside the DC or inside the on-premises DC, and even a valid user trying to access the data from outside the organization is a tough task. But with the cloud, as long as someone has internet, providing the person access is just a few mouse clicks away. Talk about implementation. Building an on-premises DC takes time. I was working on a project a few years back, and the goal to make a DC go live at that time was after 2 years from the date we were speaking about it. But with the cloud, we can bring our DC in the cloud within weeks. After all this explanation and comparisons and talking about benefits, Paul's manager was fully enlightened and wants to have his IT environment in the cloud. But our Paul is not done yet, and he took his manager through another level of discussion about the cloud, just like I'm going to take you now. So let's talk about what is cloud computing. Now, cloud computing is the ability to deliver on-demand computing service over the internet, and that too on a pay-as-you-go basis. Now, you might think, well, what does that mean? Let me explain. Now, with cloud, rather than managing files on local storage devices, cloud computing makes it possible to save them over the internet and access them from the internet. So I can be a mobile person, moving from place to place, but I can access the storage from the internet because it's in the internet. And if I want to give access to somebody else, again, it's easy for me to give access to them as long as they have internet connection available with them. Now let's move further and talk about or get understanding on the types of cloud computing. We can categorize the different types of cloud computing based on two wide categories, one being a deployment model and the other one being service model. Let's talk about the deployment model first. Deployment model is categorized into three types. First one is public, and then private, and then hybrid cloud. In other words, public cloud, private cloud, and hybrid cloud. It'll be easy for me to explain, and also it'll be easy for you to understand if I walk you through this example. Consider the different types of vehicles we use to commute from one place to another. For example, if I want to travel, I can pick a bus which is accessible to anyone. I get in and I pay for the seat that I occupy, and I pay for the time that I will be traveling in it, and I'm done. Cost is very less here. A similar kind of thing happens in the public cloud. I pay only for the resource that I use, and I pay for how long I use it. If I use less, I pay less. If I use more, I pay more for that month. Simple. On the other hand, private cloud is like buying your own car and using it for commuting purpose. Here, I pay a huge amount upfront, and it is all owned only by me. I do not pay for it in an hourly fashion, but completely and all upfront. The cost here is very huge. And thirdly, if I want the best of both types, like the comfort of the own car and still don't want to pay all upfront, otherwise want only to pay for the time that I use the service, I can rent a car. Similarly, I can have it in a hybrid environment, meaning if I already have a DC, I can integrate it with the cloud and use both the DCs, and that would become an hybrid environment. Alright, so that was good of an learning. Let's summarize the types of cloud based on deployment models. And as we know now about the public cloud is an cloud infrastructure that's made available to the general public over the internet, and it is owned by the cloud provider. Some of the major players as cloud providers are AWS, Microsoft Azure, IBM's Blue Cloud, and Sun Cloud. and private cloud. Now this cloud infrastructure is exclusively operated by a single organization. It can be managed by organizations or third party and may exist on premises or off premises, doesn't matter, but the point here is this is exclusively operated for a single organization. And some companies that provide private cloud are AWS and VMware. And hybrid cloud gives the best of both public and the private cloud. For example, the federal agencies, they opt for private clouds for storing and developing personal data, and they use public cloud to share the non-sensitive data with the general public or with other government departments. Now let's talk about different clouds based on the service model. If we need to categorize them broadly, we can categorize them as infrastructure as a service, IaaS, or platform as a service, PaaS, or software as a service, SaaS. They sometimes are referred to as IaaS, PaaS, and SaaS. Now at this moment you could be like this guy thinking, Sam, I thought you're done categorizing the cloud. Now you're going to talk about 3 more categories? Which one should I pick? Well, let me explain. If all that you want is just an VM and you have all the expertise to install the software on top of it and make it work, then go for IaaS. If you only want a platform or an interface to program or an interface to upload a program and make it run, then pick PaaS. Or if all that you want is a finished product hosted in the cloud and be able to access it through the internet, then go for SaaS. Here you get a username and password for an application and you can begin to customize the application based on your needs. Alright, let's talk about IaaS in a bit more detail. IaaS, it gives basic computing infra. It's based on a pay for what you use model. And some of the cloud providers who are big players are AWS, Azure, and Google. And here the users generally will be IT admins. In PaaS, the provider gives you a platform or a runtime environment for developing, testing, and managing application. It's platform ready. You buy the platform, you upload your code, and you start working on it. And it allows the software developers to deploy applications without running the underlying infrastructure. And as you might have guessed by now, the interesting candidates who would use PaaS is software developers. And in SaaS, everything is managed by the vendor, be it the hardware or the software. It's managed by the vendor, and we pay for the service and we pay for it through a pay-as-you-go subscription model. And as you might have guessed, the end users here would be end customer itself. Alright, let's put together everything in the same page and compare and contrast the different types of service models. In this chart, it explains the difference between the 4 models, starting from on-premises to IaaS and then PaaS and SaaS. It is self-explanatory that the resources managed by us are huge in on-premises and little less in IaaS, and further less or reduced in PaaS, and nothing to manage when it comes to SaaS. Let me also explain the different types of cloud services through an example like this. Let's say that you have a crush on cake and you're planning to bake one yourself. Now let's look at the options you can have. You can make all the ingredients yourself, be it the flour, butter, and put together and bake the whole thing yourself using your own oven, pan, the needed water, and the rest. You get an idea, right? Everything is yours, and that's on premises. All that you use is owned by you and nothing is managed by the vendor. The other options you can have is buy the ingredients and mix and bake the cake yourself. Now this would be like IaaS. Here the infra is managed by the provider and we get to use it and customize it the way we want it. Here the cloud service is a shared responsibility. The other options you still have on hand is simply pick a phone and order a cake. Now this is a lot simpler than the rest we discussed so far. It's simply picking the phone and ordering the cake and pay for it when it arrives. Simple. And when it reaches home, you will have to arrange the table, garnish the cake if that's needed, and then enjoy the cake. It's the same way with PaaS. Just get the platform in which you would run your code and upload your code and start running your application. Here you and the vendor still share the responsibility. You still have one more option left, that is simply go out and dine. This is a lot simpler, that it requires no effort from us at all. You buy the fully finished and garnished cake and pay for it and walk out. No responsibility on making the cake. It's the same way with SaaS. We buy the finished product and pay for the finished application. As next thing, let's talk about the different cloud providers. Amazon Web Services, AWS, is a cloud computing service provided by Amazon. It provides a mix of infrastructure as a service, IaaS, platform as a service, PaaS, and packaged software as a service called SaaS offerings. Microsoft Azure, formerly known as Windows Azure, is a cloud computing service by Microsoft, and it sort of specializes in using cloud for building, testing, deploying, and managing the applications through the servers throughout a global network that Microsoft manages. It also provides software as a service, platform as a service, infrastructure as a service, and it supports lots of different programming languages and tools and frameworks, including both Microsoft and third-party software and systems. IBM Cloud is a cloud computing service offered by IBM. IBM Cloud includes infrastructure as a service, software as a service, platform as a service. Now, the difference is here it offers through public, private, and hybrid cloud delivery models. VMware, on the other hand, is an subsidiary of Dell Technologies and provides cloud computing and platform virtualization software and services. It was the first commercially successful company to virtualize the x86 architecture. Google Cloud Platform, on the other hand, is offered by Google. It's a suite of cloud computing services that run on the same infrastructure that Google uses internally for its end user products such as the Google search and the YouTube we are familiar with. Alongside a set of managed tools, it also provides cloud services including computing services, data storage services, data analytics, and machine learning services. DigitalOcean, on the other hand, is headquartered in New York City with data centers worldwide. DigitalOcean provides developers cloud services that help to deploy and scale applications that run simultaneously on multiple computers. As of January 2018, DigitalOcean was the third largest hosting company in the world in terms of web-facing computers. Let's talk about cloud computing in AWS. Amazon Web Services, AWS, is a cloud computing service provided by Amazon, and these services are accessible over the internet. And because AWS provides infrastructure as a service, it's a flagship offering, we can create and deploy any type of application in the cloud on top of the IaaS that Amazon provides. And you know, the best part here is the subscriptions are pay-as-you-go type. You use less and pay less, and only for what you have used. You talk about the life cycle of the cloud computing solution. The very first thing in the life cycle of a solution or a cloud solution is to get a proper understanding of the requirement. I didn't say get the requirement, but said get a proper understanding of the requirement. It is very vital because only then we will be able to properly pick the right service offered by the provider. Getting a sound understanding, the next thing would be to define the hardware. Meaning choose the compute service that will provide the right support where you can resize the compute capacity in the cloud to run application programs. Getting a sound understanding of the requirement helps in picking the right hardware. One size does not fit all. There are different services and hardwares for different needs you might have, like EC2 if you're looking for IaaS, and Lambda if you're looking for serverless computing, and ECS that provides containerized service. So there are a lot of hardwares available. Pick the right hardware that suits your requirement. The third thing is to define the storage. Choose the appropriate storage service where you can back up your data, and a separate storage service where you can archive your data locally within the cloud or from the internet. And choose the appropriate storage. There is one separately for backup called S3, and there is one separately for archival, that's for Glacier. So knowing the difference between them really helps in picking the right service for the right kind of need. Define the network that securely delivers data, video, and applications. Define and identify the network services properly. For example, VPC for network, Route 53 for DNS, and direct connection for private P2P line from your office to the AWS data center. Set up the right security services, IAM for authentication and authorization, and KMS for data encryption at rest. So there are a variety of security products available. We got to pick the right one that suits our need. And there are a variety of deployment and automation and monitoring tools that you can pick from. For example, CloudWatch is for monitoring, auto scaling is for being elastic, and CloudFormation is define the management process and tools. You can have complete control of your cloud environment if you define the management tools which monitors your AWS resources and or the custom applications running on AWS platform. There are a variety of deployment, automation, and monitoring tools you can pick from, like CloudWatch for monitoring, autoscaling for automation, and CloudFormation for deployment. So knowing them will help you in defining the lifecycle of the cloud computing solution properly. And similarly, there are a lot of tools for testing a process like CodeStar and Code Build and Code Pipeline. These are tools with which you can build, test, and deploy your code quickly. And finally, once everything is said and done, pick the analytics service for analyzing and visualizing the data using the analytics services, where we can start querying the data instantly and get a result. Now, if you want to visually view the happenings in your environment, you can pick Athena, and other tools for analytics are EMR and which is Elastic MapReduce and Cloud Search. Alright, enough of theory, and let's have a quick look at how two services in AWS, EC2 and S3, work together and benefits us. Here are two IT professionals talking to each other. One says, I have an application which takes a lot of storage and works only on Linux system, which I do not have at the moment. And the other one is a smart guy, and he immediately replies that he could use S3 to store data and retrieve data, and use EC2 for all his compute needs. And then the curious conversation builds up, and the first person wants to know what is EC2 and S3. And the second guy starts to explain that AWS EC2 is a web service that provides a secure and resizable compute capacity in the cloud. And EC2, it can also be used to launch as many virtual servers as we need. And about S3, he explains AWS S3 is a simple storage service provided by AWS. And about S3, he explains further, saying that using Amazon S3, we can store and retrieve any amount of data at any time on the web. Alright, so the very first thing is to have an AWS account. So create an AWS account. And second thing is to create an AWS S3 bucket and upload the files there. You know, the files that EC2 server is going to pull from will get stored in S3 as first thing. Alright, so the first thing is to create an S3 bucket. So let's create an S3 bucket and let's call it as website bucket. And these names will have to be unique. So let's see if this bucket name is available. It says bucket name already taken or already exist. So let me top it up with SL, meaning Simplilearn. Alright, so we were able to create a bucket, and in that bucket let me upload a content. That basically is going to be my index file that's going to go and sit in my web server. So let me also make it public and view it. Alright, so this is the content that I have stored in my S3, and this is the content I'm going to push to my EC2 server. Alright, second step, create an AWS S3 bucket and upload files. We're done with that. Third is to create an EC2 instance. That's, in other words, create an virtual machine in the cloud. Let's go and create it. Alright, the third thing is to create an EC2 instance. So let's create an EC2 instance. It's plain and it's very simple. I'm going to keep everything as defaults here. Alright, so I've launched an EC2 instance. As you see, it's running. I also have an IP address, public IP address here. With that, I have logged into this EC2 instance, and I'm in the folder /var/www/html, and as you see, there is nothing in there at the moment. And this server also has Apache installed in it. As you can see, I browsed to the IP address of the EC2 instance, and it's showing a page, which is the default Apache page. Alright, if I had any files in this folder, that would get shown as the web page instead of the default page. Our task is to save files in S3 and move them to the EC2 instance. So S3 is going to act as a storage or a repository or a source code control in this example. Alright, so let's do that. Alright, the third step is to create your EC2 instance, and that's what we have done. And the EC2 instance has no files in it. And the fourth step is to synchronize the source code bucket with the EC2 instance. Let's do that. The actual command to do that would be AWS S3 sync, and then the name of the bucket from which we're going to pull the code, and the folder in which we're going to put the code or the data. Alright, so it has downloaded something. Look at that. And now if we go back to the test page and do a refresh, there you go. It's showing the page that it pulled from S3. So here I can use S3 as the source code control bucket, and any information that I put in there will get reflected in EC2 instance once I do a sync every day. And that's how I use S3 as my storage for EC2. Alright, finally we were able to synchronize S3 bucket and the EC2 instance. And we were also able to view the results in the web browser of the EC2 instance. The data was copied from S3 to the EC2 instance, and that we were able to view from the web browser. Alright, so what did we learn? We learned about what is cloud computing, understood the basics of cloud computing. We understood about the types of cloud computing based on deployment models and service model. And then we understood how cloud computing is with AWS, how AWS is a cloud computing service provider and the benefits of using AWS over other providers. We also looked at life cycle of the cloud computing solution, and finally we did a demo on AWS EC2 and S3, and we saw how EC2 is dependent on S3, or how we can use S3 to be dependent on EC2 and sort of act as an storage for the compute instance.
So to understand what exactly virtualization is, let's take a look at an example. So meet Jake. He works as a software developer in an IT firm, and he often has to work on different projects involving multiple operating systems. According to the requirements of the project, during which he often come across cases where the managing of data becomes problematic due to the compatibility issues with the different operating systems, which makes it hard for the completion of the project. So, what can Jake do to overcome such a problem? Well, to overcome such a problem, he decided to use the way of virtualization. But what is virtualization, and how does it help us? Well, let's take a look. To begin with, we'll take a look at what exactly virtualization is and how it can help us. Then we'll understand what virtual machines are. After that, we learn about the role and different types of hypervisor that are involved during the process of virtualization. After that, we learn what different types of virtualizations are available and how differently they affect our systems. And lastly, we will see what benefits virtualization provides us with. To begin with, we'll understand what virtualization is. Virtualization is nothing but utilizing a software to create a virtual layer over the hardware, which allows the system hardware to be used more efficiently and allows appropriate return for a hardware cost. The software hypervisor also allows the elements of the system, like storage, memory, processor, etc., to be distributed among multiple separate and secure virtual computers known as virtual machines. To understand the situation of virtualization much better, let's take a look at an example. This is a system installed with the Windows operating system, which is officially known as the host OS, where the virtualization software known as the hypervisor will run. And then using the hypervisor software, we can have multiple instances of different OS, including Unix, Mac, and Linux, which are known as virtual systems or guest OS. The working of the virtualization is only possible by using a software known as a hypervisor. And later in the video, we will also learn about the working and different types of hypervisor involved. Now that we have understood what virtualization is, let's take a look at what a virtual machine is. So as the name suggests, virtualization is nothing but an emulation or a virtual representation of a physical operating system on a hardware device. The virtual machines are also known as guest OS, whereas a physical system that they run on is also known as the host OS. Now, let's take a look at the software that makes the virtualization possible. Hypervisor is a software layer that manages the virtual machines. It forms an interface between the physical system and the virtual machine, which ensures the proper access of the resources. It also manages the virtual machines so that they don't interfere with each other's resources. Let's take a look at what different types of hypervisors are there. The first type of hypervisor is known as the Type 1 hypervisor, or the bare metal hypervisor. This type of hypervisor directly interacts with the hardware system and user resources. The other type of hypervisor is known as the Type 2 hypervisor, which runs as an application on the host operating system, and the hypervisor also coordinates with the virtual machine for resource management. Let's take a look at the Type 1 hypervisor. They run directly on top of the host operating system and utilize the hardware resources. And that is why they're also known as the bare metal hypervisor. They take up the place of the host operating system and works as the own operating system. And since this type of hypervisor works directly on the hardware system, they are highly efficient. Now that we understand Type 1 hypervisor, let's take a look at the Type 2 hypervisor. This type of hypervisor doesn't directly work on the operating system hardware, but instead it works as an application in the host operating system where they are suitable for running individual systems. Users can also have different multiple OS installed in the physical system by using this type of hypervisor. Due to the application-based working of the Type 2 hypervisor, they are also known as virtual machine monitors, or in short, VMMs. Now that we understand what different types of hypervisors there are, let's take a look at what types of virtualizations are present. The first type of virtualization is the desktop virtualization, then the network virtualization, storage virtualization, and lastly, the application virtualization. Let's take a look at them one by one. For desktop virtualization, as the name suggests, in this type of virtualization, we can run multiple operating systems on a single hardware system. Let's take a look at the different types of desktop virtualization. The first one is Virtual Desktop Infrastructure, or in short, VDI, which runs numerous virtual machines on a central server and then hosted to the user according to the user's requirement. In this way, the user can access any operating system without having to physically install the particular operating system in its hardware system. The second one is known as Local Desktop Virtualization. As the name suggests, it uses a hypervisor software on a local system, which allows a user to run multiple operating systems simultaneously without having to affect the host operating system. The next type of virtualization is network virtualization. In this type of virtualization, the software creates a virtual instance of the network that can be used to manage from a single console. And it also forms the abstraction of the hardware components and functions, including switches, routers, and etc., which simplifies the network management. Different types of network virtualization are software-defined virtualization, which virtualizes the hardware that controls the network traffic routing, and the other one is network function virtualization. Virtualize is the hardware appliances that provide network-specific functions easier to configure and manage, for example, a firewall. Let's take a look at the third type of virtualization, known as the storage virtualization. This virtualization enables all the storage devices on the system to be accessed and be managed as a single storage unit. The storage virtualization collects all the storage into a single pool from which they can allot another virtual machine on the same network as required. And this makes it easier to assign storage for multiple virtual machines with maximum efficiency. And the last virtualization that we'll discuss is the application virtualization. In this type of virtualization process, the application runs directly without the need of installing it into the system, as they run on a virtual environment. Different types of application virtualization the local application virtualization, and this type of application runs on the host device, but runs in a different virtual environment, but not in the hardware. The second one is application virtualization, and in this, the application is on the server side, and it sends some of the components to the host device according to the requirement. And last is the server-based application virtualization. This application runs directly on the server side and sends only the interface to the client system. Now, let's take a look at the benefits of virtualization. The first one is resource efficiency. As the name suggests, before virtualization, each application server used its own hardware resources, which were being underused. But with having multiple virtual machines, maximum utilization of the hardware capacity occurs. Then we have minimum downtime, which refers to the crashes of operating systems and applications, which can cause a halt in the user productivity. By using virtualization, the admin can run multiple similar virtual machines simultaneously and change over the working instances in case of a crash instead of having multiple dedicated servers. And then we have time management. Buying, installing, and configuring a new system is not only costly, but also a waste of time. In such a case, virtualization can solve the problem provided that the existing hardware resources are sufficient for running the virtualization software. Otherwise, it can be configured for the same.
Meet Rob. He runs an online shopping portal. The portal started with a modest number of users, but has recently been seeing a surge in the number of visitors. On Black Friday and other holidays, the portal saw so many visitors that the servers were unable to handle the traffic and crashed. Is there a way to improve performance without having to invest in a new server? Wondered Rob. A way to upscale or downscale capacity, depending on the number of users visiting the website at any given point? Well, there is. Amazon Web Services, one of the leaders in the cloud computing market. Before we see how AWS can solve Rob's problem, let's have a look at how AWS reached the position it is at now. AWS was first introduced in 2002 as a means to provide tools and services to developers to incorporate features of Amazon.com to their website. In 2006, its first cloud services offering was introduced. In 2016, AWS surpassed its $10 billion revenue target. And now, AWS offers more than 100 cloud services that span a wide range of domains. Thanks to this, the AWS Cloud Service Platform is now used by more than 45% of the global market. Now, let's talk about what is AWS. AWS, or Amazon Web Service, is a secure cloud computing platform that provides computing power, database, networking, content storage, and much more. The platform also works with a pay-as-you-go pricing model, which means you only pay for how much of the services offered by AWS you use. Some of the other advantages of AWS are security. AWS provides a secure and durable platform that offers end-to-end privacy and security. Experience. You can benefit from the infrastructure management practices born from Amazon's years of experience. Flexible. It allows users to select the OS, language, database, and other services. Easy to use. Users can host applications quickly and securely. Scalable. Depending on user requirements, applications can be scaled up or down. AWS provides a wide range of services across various domains. What if Rob wanted to create an application for his online portal? AWS provides compute services that can support the app development process from start to finish. From developing, deploying, running, to scaling the application, up or down based on the requirements. The popular services include EC2, AWS Lambda, Amazon Lightsail, and Elastic Beanstalk. For storing website data, Rob could use AWS storage services that would enable him to store, access, govern, and analyze data to ensure that costs are reduced, agility is improved, and innovation accelerated. Popular services within this domain include Amazon S3, EBS, S3 Glacier, and Elastic File Storage. Rob can also store the user data in a database with AWS Services, which he can then optimize and manage. Popular services in this domain include Amazon RDS, DynamoDB, and Redshift. If Rob's businesses took off and he wanted to separate his cloud infrastructure or scale up his work requests and much more, he would be able to do so with the networking services provided by AWS. Some of the popular networking services include Amazon VPC, Amazon Route 53, and Elastic Load Balancing. Other domains that AWS provides services in are analytics, blockchain, containers, machine learning, Internet of Things, and so on. And there you go. That's AWS for you in a nutshell.
AWS. Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store the data and share it with their customers. But prior to AWS, they had some issues. Imagine using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily. How easily, one might ask? It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital cost. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100 plus services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service. Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL, or American Online, uses AWS, and using AWS they have been able to close data centers and decommission about 14,000 in-house and co-located servers and move mission critical workload to the cloud and extend its global reach and save millions of dollars on energy resources. Bitdefender is an internet security software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses EC2, and they're currently running few hundred instances that handle about 5 terabytes of data, and they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon CloudFront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS, and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's largest leading business news organization, and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight, and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FT is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads including 300 disparate ERP systems to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS, and if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data, and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained. Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy-to-use service for deploying and scaling web applications and services deployed be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code, and Elastic Beanstalk automatically handles the deployment from capacity provisioning, networking to load balancing to auto scaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere. Websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System or EFS provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. And Amazon Elastic File System, it's simple, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the application, growing and shrinking automatically as you add and remove files so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic load balancing, it's also a network and content delivery service. Elastic load balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instance, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zones and also across availability zones. AWS auto scaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS auto scaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Auto scaling can be applied to web services and also for DB services. AWS Identity and Access Management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. Cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy an web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3, and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage, and S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment, and CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well, and it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing. And now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? All right, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. All right, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL. So what did we learn? We started the session with what is AWS. We looked at features and tools, technologies, products that AWS provides. And we also looked at how AWS became very successful. Again, we looked into the benefits and features of AWS in depth. And we also looked at some of the services that AWS provides in random. And then we picked particular services and we talked about them like EC2, Elastic Beanstalk, Lightsail, Lambda, storage, stuff like that. Then we also looked at the future of AWS, what AWS holds in the store for us. We looked at that. And then finally, we looked at a lab in which we created an application using Elastic Beanstalk, and all that we had to do was a couple of clicks and boom, an application was there available that was connected to the database, and that was connected to the simple notification system, that was connected to CloudWatch, that was connected to storage, stuff like that.
What's in it for you? I would be covering up what is AWS, the Amazon Web Services, what are the benefits of using AWS as a cloud, and the different AWS services. That would include compute service, storage service, database service, networking service, security service, management tool service, developer tool service, likewise. And then I would be covering up demo on those essential AWS services. Let's look into what is AWS. AWS is a broadly adapted cloud platform which offers several on-demand operations like compute power, database storage, content delivery, etc. And that helps corporate scale and grow. AWS services can be used to create and deploy any application in the cloud. For example, it provides services over the internet just like World Wide Web. And AWS is the largest cloud platform available that you can use for either creating the application, creating the databases, likewise the other features also you can use simultaneously. Now, what are the benefits of AWS? The first is it is easy to use. For using the AWS, you require the good internet connectivity, and then you can actually browse it using the web console. And also you can use the command line interfaces as well. Second, flexibility. AWS offers you a flexibility so that you can actually change or tweak your solutions whenever you require. Reliability. So with the help of the redundant infrastructure across the globe, the AWS gives you the reliability that any application or any databases, if you are running on the AWS, that would be basically up all the time and there will be no or very less downtime Then comes the scalability. So scalability is one of the important features of AWS, and in that case you can actually scale up your resources at any time you require. So for example, if any of your application is overutilized and you require more resources to run your application, you can do that on the fly. Then comes cost effectiveness. So AWS is a very cost effective platform because here whatever the service that you use, that is charged on a per hour usage only. So you don't have to pay the complete cost like you do when you procure the infrastructure in the data centers. You don't have to basically pay for the complete package or usage of the service. You just have to pay for whatever time duration that you have actually used that service and the associated charges with it. And that makes the AWS a very cost-effective solution. Then comes the security. So AWS is a secure platform and a lot of measures have been taken so that the security can be enhanced and upgraded in the AWS. So from the infrastructure level, the AWS have a very high level of security that is implemented, and from the application and the solution perspective, it gives you a lot of features where you can actually apply the security as per your requirement onto your applications. Coming to the AWS services, so essential AWS services are compute, storage, database, migration, networking and content delivery, developer tools, management tools, media services, machine learning, analytics, security, identity and compliance, mobile services, application integration, AR and VR, which is augmented reality and virtual reality, customer engagement, business productivity, desktop and app streaming, Internet of Things, which is IoT. Now let's look into the compute service, which is one of the widely used service on the AWS. And what does the compute service do? These services help developers build, deploy, and scale an application in the cloud platform, that is EC2, Lambda, Elastic Container Service, Elastic Load Balancer, Lightsail, and Elastic Beanstalk. These are the services which lie in the compute service section only. One of the most widely used service within the compute section is EC2, which stands for Elastic Cloud Compute. It is a web service that allows developer to rent virtual machines and help to resize the compute capacity. So here what you can do is you can run the virtual machines and you have the privileges to select the type of operating system that you want should be running on your instances or on your virtual machines. And likewise, later you can customize as per your requirement. Lambda is a serverless compute service. It is also responsible to execute code for a specific application. So those who are from the development background, they can focus more on creation of a code. They don't have to create a server, manage it. Instead, they can use a Lambda where they can deploy their code directly onto the Lambda server. Then comes this storage service. Now, couple of storage services are S3 Glacier, EBS, which is Elastic Block Storage, Storage Gateway. Now, AWS provides web data storage service for archiving data. Also, its main advantage is disaster data recovery with high durability. Let's look into some of the essential storage services, and one of the most widely used storage services is S3, which stands for Simple Storage Service. In the Simple Storage Service, what you need to do is you have to create a bucket, and in that bucket you have to put the files in it. So S3 gives open cloud-based storage service which is utilized for online data backup. Then comes the EBS, which is an Elastic Block Storage. Now you can understand EBS as a virtual hard drive also, which attaches with the EC2, and it provides high availability storage volume for persistent data. It is mainly used by Amazon EC2 instances. Then you have the database services. AWS Database Domain Service offers cost-efficient, highly secure, and scalable database instances in the cloud. And some of the database services are RDS, which is a relational database service, DynamoDB, the non-relational or NoSQL or NoSQL database service, Elasticache, and Amazon Redshift. Now, one of the essential database service is the DynamoDB. It is a flexible NoSQL database service which offers fast and reliable performance with no scalability issues. It is fast, reliable, highly scalable, and suitable for small scale applications like mobile applications, gaming applications, or anything with respect to the Internet of Things devices. There, the DynamoDB is most widely used or suitable. Then comes the relational database service, that is the RDS, which is a structured database service. It is a managed distributed relational database cloud service that helps developers to operate and scale database in a simple manner. So RDS has different vendors platform with respect to the database usage, and that includes the PostgreSQL, MySQL, then you have Oracle, Microsoft or MS SQL, and they have their own customized database as well, that is called as the Amazon Aurora. Along with that, they have a Maria database or MariaDB as well. So these are a couple of vendors that give their database engines that you can use on the RDS. Now coming to the networking services, it offers a highly secure cloud platform and helps in connecting your physical network to your private virtual network with high transfer speed. Now, some of the services in the networking and content delivery are VPC, which is a virtual private cloud, a very important service in order to make your applications or services more secure. Route 53, which is a DNS mapping service. Direct Connect, which directly connects with the AWS services and with your data centers. And the CloudFront, that is basically a content delivery service. Now coming to the VPC or a virtual private cloud, it helps a developer to deploy AWS resources such as Amazon EC2 instances in a private virtual cloud, so that you can actually make your EC2 isolated or make it more secure, and even you can make it for a public access also. Depends on the administrator that how they want to customize it. So the complete control of a VPC and its networking is with the admins. Then comes the Route 53 service. It is a web service with highly available domain name system or the DNS that helps user to route software by translating text into IP address, and that is why it is called as a DNS mapping service. And that helps you to use your domains or the external domains pointed to the AWS services in case if you use AWS for hosting your websites or the applications. Note, DNS translates text into the IP address. Now coming to the developer tool services, it helps a user build, deploy and run an application source code automatically. It also updates the server and instance on the workload. So first is the CodeStar, Code Build, Code Deploy, Code Pipeline. So CodeStar, it is a service designed to manage application development at a single place. Here developers can quickly develop, build and deploy applications on AWS. So all the managed app development can be done with the CodeStar. Code Build removes the hassle of managing physical servers and helps developer build and test code with continuous scaling. So security, identity and compliance services helps in monitoring a safe environment for your AWS resources by providing limited access to specific users. So in case, let's assume that you have to give an access to someone but with limited privileges, you can primarily use IAM in that case. And if you want to make your applications or deployments more secure, then you can use these services like KMS, IAM, Cognito, WAF, which acts as a firewall. Now, the IAM service, which is the Identity Access Management, is a framework that helps in maintaining access to AWS services in a secure way. So what happens is that the admin who has the complete access of the AWS console provide access to users, and there can be different users, and they would have the privilege accesses defined by the admin. So what type of permissions the admin gives them, they would have those limited access on the AWS console. KMS enables users to create and manage the encryption keys that are used for encrypting data. Coming to management tool services, with the help of management tools, using this service, an individual can optimize costs, minimize risk, and automate all the resources running on the AWS infrastructure efficiently. So with the management tools, you can monitor the resources application, its tools and the utilizations, and along with that you can scale up, scale down the resources likewise. With the help of the management tools, you can also do the auditing task. So one of the essential service in the management tool service is the CloudWatch. It is a monitoring tool for AWS resources and customer applications running on AWS platform. So let's assume that you have used EC2, DynamoDB, S3, RDS, and you want to monitor those resources. You can use the CloudWatch that can give you the results. Coming to the CloudFormation, this service helps you in monitoring all your AWS resources at one place so that you can spend minimum time in managing those resources and maximum time on developing the application. So with the help of the CloudFormation, you can deploy the entire solution with the help of creation of a template. You just need to create one template and you have to deploy it. The rest of the things will be done by the AWS, and hence it is a kind of an automation task only. Now let's look into the demo of some of the essential services. So we'll start with the EC2, and I have already logged in into my AWS account. So where exactly you can find the EC2? Just click on the services. Under the compute section, you can find the EC2. EC2 stands for Elastic Cloud Compute Service, primarily used for creating the virtual machines. So I'll click on this service and quickly I'll show you how the virtual machine is created and how we can basically access it. So I would be creating one virtual machine or an instance with the Windows operating system. So here you can see there are 3 instances which are already running. Let me create another one. So you have to click on Launch Instances, and here you have to select some configuration details. So most of the configuration details I'll be taking as default, and wherever it is necessary I'll be making the changes. So first of all, you have to select the operating system in the form of AMI, and I would be looking for Windows 2016, and then you have to select the type of instance with respect to the CPUs, number of CPUs, and the memory capacity. So I'll go with T2.micro, which is a free tier eligible instance. In the configure instance details, the rest of the things we'll keep it as default as of now. Click on Add Storage. This is basically the virtual hard drive, or the EBS, the Elastic Block Storage, that is attached with the EC2 instance. So primarily it is giving us 30 GB of space without any additional cost. We can leave the tags as blank. Click on Configure Security Groups, and here you can see that the RDP port is by default open, which will actually allow us to RDP, or to have a remote connectivity of our instance. Click on Review and Launch. Now to give an authentication, or to provide an authentication, we should have a key pair with us so that the AWS can understand or can tally the key pair and give us the access. So I already have a key pair created. What I'll do is I'll create a new key pair for this instance and put a random name. Let's say I put it something like demo. Download the key pair and make sure that you keep your key pair in a safe and secure place. Click on Launch Instances. Now you will see that there is an instance ID that has been created, which is a number, alphanumeric number, that is randomly given by the AWS. You can name your instances. So let's say we name our instance as Windows 2016. Click on Save. and the AWS deploys our instance on a respective infrastructure. It gives us the IP addresses, the public IP and the private IP, which is an internal IP, and we have to access the instance from the public IP only. So now to access that instance, we have to open up the RDP, put the public IP, click on connect, and when it asks you for the authentication, you put a username as administrator and the password you have to generate by providing the key. So click on connect, and then you have to click on RDP client. Here you have to get a password. So click on get password, browse, and when you click on browse, you have to provide demo.pem file. So it should be in the download section here itself. Just provide that key pair and it is going to give you the password in the encrypted format. Decrypt your password, copy that, and then provide those details to the RDP client. Click on OK, and now it should allow you to log into the instance. Let's wait for the windows to appear. So here you can see that we have logged in into the Windows instance. The Windows 2016 screen is available in front of us.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
In this particular demonstration, I would be explaining you about how to use a storage service, specifically the S3 service, which is most widely used service under the storage section. Now the S3 stands for Simple Storage Service, primarily used for storing the objects and the files. And what we need to do is we just have to click on the S3 service under the storage section. So when you click on S3 service, you have to create the buckets inside the S3. And the buckets are the places where you keep your folders or you upload the files that are available on your systems. So here if you'll notice that the S3 service is a global service. That means it is irrespective of the region. And the buckets when you create, they are created in a specific region. Now what is the benefit? The benefit is that if you create a bucket in different regions, all those buckets in different regions can be viewed from a single dashboard. And you don't have to change the region again and again to view the S3 buckets. So what you need to do is you have to click on create bucket, and here you have to specify the name of the bucket. So let's say I put something like demo AWS, and that's the bucket name I am going to select. Now make sure that the bucket name starts with a lowercase and it should be always unique. Now why it should be unique? Because since S3 is a global service, so it may be that somebody else could be using the name that you have provided. So it should be always unique, otherwise it will not be allocated. Now you have to select a region, and that would be, let's say I go with the Ohio region. And in the bucket settings, you can basically change and configure these settings according to your requirement. By default, when you create a bucket, it blocks all the public access from the bucket. So when you have all public access blocked, no object can be viewed from the S3 bucket from a public network or by anyone else. And hence, in order to view the objects or the files in the bucket, you have to unblock or uncheck this option, so that first of all you make the bucket accessible from the public network. Likewise, you can customize as per the requirement, and then click on acknowledgement. The rest of the things we'll keep it as default, and click on create bucket. Now it says that the bucket with the same name already exists, so that means it is not a unique name. Somebody else might have been using this name. So I'll try to keep it more unique, and I'll try to assign some number. So let's say I put something like 987, and it says it has already existed. Let's say 9876, and then click on create bucket. Now if it creates a bucket, that means we have been allocated with that bucket name. So let's wait for wait for a minute to get that bucket created. So that happens quickly, and you can see there are a couple of buckets already created here, and these buckets can be viewed in a single dashboard. So some of the buckets are in Mumbai region, some of the buckets are in Ohio region, but they are available in the same or a single dashboard. So I'll open up the bucket that I have recently created, and I'll try to upload some documents. Now what you can do is you can create a folder also inside the S3, and when you create a folder you can upload the objects accordingly. Otherwise you can directly also upload the objects. So click on upload, and we will upload any random file from my system onto the S bucket. So I'll basically file and then click on upload. Now it is uploading my object from my system onto the S3 bucket, and now it has successfully done. So it says the message is successful. Now in order to validate, I will click on the bucket from the S3 service and view this object. Now you can see here is my bucket. So I'll just open up this bucket, and these DNS records.csv file is available with us. Now the S3 is not only limited till storing the objects or the files. It has many other functionalities and the features also. Like you can enable versioning, you can host a static website on the S3. Along with that, you can have a cross-region replication enabled so that you can have high availability of your objects, or you can have a redundancy of your critical objects in different regions. So likewise, there are more features that would be covered up in the detail section of an S3 service. Now coming to another section of the essential services, that is the database. Now here you can see I have a database section in the AWS, and it has multiple services within it. The RDS is there, DynamoDB is there, Elasticache, and the other database services are there. So I would be showing a demo on the DynamoDB, which is a NoSQL database. Now, when we say it is a NoSQL database, that means it is a non-relational database service where we can create a database table directly from the web console. We don't require a separate database engine like in the case of RDS. And in the tables, you can insert the values and view those values directly from the AWS dashboard itself. So it says Amazon DynamoDB is a fast and flexible NoSQL database service primarily suitable for IoT and web gaming and other mobile applications. So what you need to do is, it is a straightforward database service which can be accessed while creating a table itself, and it's a compute based database service. That is the reason that it is more fast. So click on create table, and what you need to do is you just have to put a table name. So I'll just put something like test, and in the partition key, so these partition keys are unique entities. So what you need to do is you have to specify a partition key. So I'll put something like ID, and the string, instead of string, I'll use a number. Likewise, I can add sort keys also. Let's say I put a name, and the name should be in the string format. Now these are the unique entries. These are the fixed entries in the table. And after that, we are going to put the attributes, and in the attributes, the data will be inserted. So what you need to do is, rest of the things we'll keep it as default as of now. Click on create. And here you can see the table has been created. The test table has been created. Now if I click on the items, so you would see that it has the sort keys available, the ID and the sort key associated with that, that is the name. But it does not have any entry because we have not added any value or the attributes. So how we can add or insert the values in this table? That can be done many ways. You can enter manually. You can use the help of CLI to enter the large chunk of data directly, upload it onto the DynamoDB table, and also you can use the APIs also in order to insert the data inside the table. So what you will do is, we will click on create item, and in the ID we will put some value. Let's say number 1 string. Let's say we put something like we will go with a random name. So instead of putting any name, we'll put a value like ABCD. That should be fine. And then we will insert some attributes. So let's say I put string as rank, and I'll put something like rank 2, and then click on save. So here you will see, just refresh the database table, close it and open it up again. Click on the items. Now here you can see the ID 1 name is ABCD, got the rank 2. Likewise, you can click on create items. Let's say the serial number or the ID 2 name. Let's say we put something like we can go with XYZ, any random thing, put it up as number rank, and let's say this particular value got a rank 3. Likewise, you can add some more items. String, let's say you put something like HJK, and you put a rank, let's say it's a rank number 1 holder, rank 1 holder, right? So likewise, this is just an example. Likewise, you can add the attributes as per your need, and the table can be filtered out based on the attributes also. So if you have to search some values in the DynamoDB table, so you can always use filters to basically search the values inside the table. Apart from that, the DynamoDB table has a lot of other functionalities. It can be basically, you can have a backup of a table created in the DynamoDB table, in the Dynamo database, and then you can retrieve or recover the data by restoring the backups from the DynamoDB. This database can be created in the cluster format also. So these are a couple of features that you can use with the DynamoDB. Now let's move into the next section. Now coming to the networking services, so there are some of the networking services which are very useful, and that includes a VPC, which is a virtual private cloud, CloudFront, Route 53, API gateway, etc. Now I will basically demonstrate about the Route 53 service in this demo. So in the Route 53 is basically a DNS mapping service. So what you can do is, let's assume that you are hosting any web application on the server and you want to route the domain traffic onto those servers. You need to have the help of Route 53 to do that. So what you need to do is, you just have to click on Route 53 service. And from this service, you can register your domains also. Otherwise, if you have domains purchased from any external site, you can point them to the Route 53 name servers also. So first of all, in the Route 53, you have to create a hosted zone. So there is already one hosted zone all created. Now, when you create a hosted zone, you have to specify the domain name. So let me show you. I have one dummy domain. This is the domain that has been defined. So what you have to do is, when you click on create hosted zone, you have to put a domain. Here you can see example.com. Likewise, you have to put your own domain, and click on the public hosted zone, click on create hosted zone, and it is going to give you 4 name servers. Now those 4 name servers have to be updated on the platform from where you have purchased the domain. So that is mandatory in order to route the traffic to the Route 53 service, right? So here you can see I already have a hosted zone created for a domain, and it has given me 4 name servers. These are the name servers, and these name servers have been updated in a record set from where the domain has been purchased, right? Once it is done, then you have to route the domain traffic to a server. So what you have to do is, you have to click on create record, and in the create record you have to specify the IP address, or you can use the alias also, where the traffic should be routed to, where your application is hosted at. So ideally it is the server details, and it exists with certain policies also. So you can see some view existing records. So here you can see this particular domain is routed to a DNS value which is hosted in the Elastic Beanstalk. Instead of that, you can put an IP address of the EC2 instance also. You can use the S3 URL also. You can use the CloudFront URL also. So likewise, what would happen is that the domain traffic will be routed to the server where actually the application or a web application is hosted at. Now, I'm using a routing policy as simple routing policy. That means all the traffic should be routed to that particular domain. Whereas there are other routing policies also in the Route 53 that includes the weighted routing policy, which acts as a kind of a load balancing, geolocation routing policy, multi-value answer routing policy, and then you have a redundancy based routing policy, which is a failover one. So likewise, you can select as per your requirement. So what you need to do is you just have to click on create records. You have to specify, you have the domain, so you have to specify any particular info you want to put before the domain, otherwise you can leave it as blank. And in the record type, let's assume that you are using an IP address of a server where your web application is hosted at, so you can basically use A routes traffic to an IPv4 address and put an IP address. Make sure that you put a public IP address or the elastic IP address attached to your instance. In case if you are not using any particular IP address or the URL, you can use the alias also. So likewise, the records can be created. Along with that, the Route 53 service is used for domain verifications also. Like if you want the email services onto your web application, then you can basically verify your domain directly from the Route 53 service. You can get the verification done for the SSL certificate creation. For that also, the records will be directly created from the Route 53 service because it is actually managing or hosting your domain. Now with respect to the security services, the most widely used service is the IAM, which is Identity Access Management. That lies under security, identity, and compliance. So from the IAM, you can create the users whom you want to give an access to your AWS console. You can create groups and you can add multiple users in that group, give them the permissions. You can create the roles also so that multiple services can interact or integrate it together. So how the IAM is used, click on the IAM service and I'll show you how a particular user can be created and how the user is basically uses the credentials to access the AWS console. Now the IAM dashboard is open, and when you open up the IAM dashboard, it gives you the URL. So this is the URL through which the user has to actually access the AWS console by providing the user credentials. Now how the users are created, just click on the users and here you just have to click on add user. So I'll create one sample user. Let's say I put something like sample user. And what type of an access you want to give that particular user? Do you want to give a programmatic access, which is primarily the CLI access, or you want to give the AWS Management Console? So right now we'll go with the AWS Management Console access. Now, do you want an auto generation of the password or do you want to customize the password? So let's assume that we customize the password. So put any value. Make sure the password meets all the criteria and then click on next permissions. Now, what kind of permissions you want to give to that user? Let's assume that you want to give an access of a particular service only to that user. So you have to actually search a policy for that particular service that can be given an access to a user. Otherwise, if you want to give an admin policy or the admin access to that user, you can search an admin policy there. So the permissions are important, otherwise the user would not have privileges to access the AWS console. So we'll attach the existing policies directly. So click on it. And here, let's assume that I want to give an admin access to that user. So I'll just click on the admin access. Now, to a particular user, you can give multiple policies also. It is not necessary that you have to give only a single policy. So you can provide a multiple policies to the users also. Now click on next tags. Let's make the tags blank. Click on review and create a user. Now you'll see that our sample user would be created, and to access the console, we'll just copy this URL, which has the account information as well, that is the account number. So copy the link, or you can copy the complete URL. Log out from the root account. And then paste the URL that was copied from the console. And then we have to give the user credentials. So we'll put sample user as the username and the password that we provided while creating the user. Click on sign in, and if it is correct, then it should allow us to log in into the AWS console while asking the password change. So we'll change the password. Confirm password change. And now it should allow us to log in into the root account's AWS console with the admin privileges. Now the next service is the monitoring services, and under the monitoring services, primarily the CloudWatch, the CloudTrail, the CloudFormation, these are some of the services that are most widely used. Now the CloudWatch is a service which is primarily used for monitoring the metrics, primarily of the servers. Like for example, if you create an EC2 instance and you want to basically watch out for the metrics associated with the CPU utilization or the storage utilization, the network in, network out, all those information you can get it from the CloudWatch. Now CloudWatch is not only related to monitoring the metrics, it can generate the alarms also, and here you can get the events also generated, which or the events that can be created, which can trigger the Lambda function as well. So what you have to do is you just have to click on a dashboard. So monitoring metrics are viewed with the help of the CloudWatch. So first of all, you have to create a dashboard. Now you have to put a dashboard name. Let's say I put something like monitoring EC2. Click on create dashboard. Now how do you want the reports to be published? You have to actually select a widget. I want that, okay, the report should be visible in the numeric form. So I'll select a number. Now click on the dashboard that was created, and let's again add the widget. And here we'll select the metrics primarily for the EC2 per instance metric. So we have one single instance running. Now there are 14 metrics available for that particular instance. Now I would be looking for the CPU utilization for this particular instance. So I'll just select for the CPU utilization, and it is going to give me some information about what is the current CPU utilization of that particular instance. So that is somewhere around 29.3%. The CPU utilization has been done for the single instance that is running in my EC2 dashboard. So likewise, you can add some more metrics and view them in this particular dashboard, and the CloudWatch will keep on publishing the data at a refresh interval of 5 minutes. That is the default value.
Let's talk about what we'll be covering in this video. First, we'll talk about why you should be interested in cloud computing. What exactly is cloud computing? What is Microsoft Azure? Some of its services and the users of Azure. Now, let's start with why you should be interested in cloud computing. Now, let's say you have an idea for a revolutionary application. An idea that ticks both the boxes when it comes to good applications. One, it has great user experience. And two, it'll be highly profitable. Now, for it to be successful, you'll have to release it on the internet. People need to use it, they need to spread the word, and then it'll become truly famous. However, for that, you're going to need servers, storage, developers, a dedicated network, and application security to ensure your application works the way it does. Now, these are a lot of components, and that's where the problem lies. There are two major disadvantages to this approach. The initial setup is very expensive and risky, which means this requires a huge amount of capital upfront to ensure that it works properly. And the downside is, if your application does not become famous or it doesn't return as much as you expect it to, you're probably not going to get the money back, which means it provides a huge amount of risk. And then on the flip side, if it does become famous, your number of users have increased, which means that you'll have to buy more servers and storage systems to keep up with your demand. And this problem can be solved with the help of cloud computing. Now that you know why you should be interested in cloud computing, let's go into the details of what exactly is cloud computing. Now, cloud computing is basically a platform that gives you access to a number of computing resources. And this is possible with the help of the internet. Now, as a user, all you need to do is go to a cloud service provider through your laptop or your computer, through the internet, of course, connect to that cloud service provider, and then there you go. You have access to computing resources. Now, computing resources may include, serverless computing, virtual machines, storage, and so much more. Now, let's dig a little deeper. Now, basically, these cloud service providers actually have massive data centers. Now, in these data centers, what you have are hundreds of servers. Also included are storage systems and mainly several organizations' critical components. So these are very secure, safe locations where a large amount of data is stored, hence the name data centers. Now, it is to these data centers that users actually connect to collect their data or use it. So actually, users can access any service based on their requirement. Now, like I told you, there's a number of services the user can use. For example, now if you want a notification every time someone sends you a message, or perhaps once you get an email, you need a copy of it created. Now, for all of this, there are services. And most importantly, almost every cloud service provider has this option where users only pay for the service that they use. So there's no charge upfront where they tell you that you need to pay X amount of money so that you can use our services. You're only paying for the amount of time that you're using these services. Now, cloud computing is used for a wide variety of reasons. Firstly, there's machine learning and data analysis. Now, basically, there are services that analyze your data and tell you how you can work with this data better. Then there's data storage and backup, streaming media content. For example, did you know that the shows that you watch on Netflix, actually all of them are in the cloud. So you're connected to the internet and you browse through Netflix and you get access to the videos. These are possible with the help of cloud service providers. There's creating and testing applications, automating software delivery, which is a component in DevOps, and hosting blogs and applications. So now, what is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now, it's basically an online portal through which you can access and manage resources and services. Now, resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched on February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure Services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure Services. Now, Azure Services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it, All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have Express Route. Now with this, you can actually connect your on-premise network onto the Microsoft Cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have Virtual Network. Now with Virtual Network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development. It could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices. For example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines where these services are able to provide you a large amount of storage where data can be stored.
In a city not so far away, a CEO had plans to expand his company globally and called one of his IT personnel for an IT opinion. And this guy has been in the company for a long time and is very seasoned with the company's infra. And he nicely answered the questions with what he foresaw. And he said, I have a good news and a bad news for us to go global. And he starts with the good news. He said, Sir, we're well on our way to become one of the world's largest shipping company. And the bad news is, however, our data centers have almost run out of space, and setting up new ones around the world would be too expensive and very time consuming. Now the IT personnel, let's call him Mike, now he explains the situation from how he saw it. But the CEO had done some homework about how he was going to do it, and he answered Mike saying, don't worry about that, Mike. I've come up with a solution for a problem and it's called Microsoft Azure. Well, Mike is an hard-working and honest IT professional working for that company, but he did not spend time on learning the latest technologies. And he asked this question very honestly, oh, how does it solve a problem? And the CEO begins to explain Azure to Mike, and he starts with what is cloud computing, and then he goes on and talks about Azure and the services offered by Azure and why Azure is better than the other cloud providers, and what are the great companies that uses Azure and how they got benefited out of it. And then he winds it all up with the use cases of Azure. So he begins his explanation saying Microsoft Azure is known as the cloud service provider, and it works on the basis of cloud computing. Now, Microsoft Azure is formerly known as Windows Azure, and it's Microsoft's public cloud computing platform. It also provides a range of cloud services, including some of them are compute, analytics, storage, and networking. We can always pick and choose from these services to develop and scale our applications, or even plan on running existing applications in the public cloud. Microsoft Azure is both a platform as a service and infrastructure as a service. Let's now fade their conversation out and let's talk about what is cloud computing, Azure, services offered by Azure, how is Azure leading when compared to other cloud service providers, and what are the companies that are using Azure. Let's talk about that. In simple terms, cloud computing is being able to access compute services like servers, storage, database, networking, software analytics, intelligence, and a lot more over the internet, which is the cloud, with the flexibility of the resources that we use. Like anytime I want a resource, I can use one and it becomes available immediately. And anytime if I want to retire a resource, I can simply retire a resource and not pay for it. And we also typically pay only for the services that we use, and this helps greatly with our operating cost to run our infrastructure more efficiently and scale our environment up or down depending on the business needs and changes. And all the servers and storages and databases and networking, all that are accessed through the network of remote systems or remote computers hosted in the internet, typically in the provider's data center, which is Azure in this case. Now, we don't use any physical server or an on-premises server here. Well, we still use physical servers and VMs, hosted on a hardware or a physical server, but they're all in the provider's environment and none of them sit on premises or in our data center. We only access them remotely. It looks and feels the same, except for the fact that they are in a remote location. We access them remotely, do all the work remotely, and when we're done, we can shut it down and not pay for them. So some of the use cases of cloud computing are creating applications and services. The other use cases are storing or using cloud for storage alone. If there is one thing that ever grows in our organization, is the storage. Every new day there is a new storage requirement, and it's very dynamic. It's very hard to predict, and if we go out and buy a big storage capacity upfront, until we use the storage capacity fully, the empty storages, we're wasting money on them. So instead, I can go for a storage which scales dynamically, that's in the cloud. Put storage or put data in the cloud and pay only for what you're storing. And for the next month, if you have deleted or flushed out some files or data, pay less for it. So it's a very dynamic storage in the cloud, and a lot of companies are getting benefited from storing data in the cloud because of its dynamic in nature and the cost that comes along with it, the cheap cost that comes along with it. And also they give a lot of the providers like Azure, they give data replication for free. They promise an SLA along with the data we store in the cloud. So there's an SLA attached to it. And they also provide data recoveries as well. If in case something goes wrong with the physical disk where our data is stored, Azure automatically makes our data available from the redundant or other places where it had stored our data because of the SLA they wanted to keep. The other use case for Azure is hosting websites and running blogs using the compute service. be it storing music and letting your users stream the music, Azure is a good place to store music and stream the music with the benefit of CDN, Content Delivery Network, which allows us to stream video or audio files with great speed. With Azure, our audio or video application works seamlessly because they are provided to the client with very low latency, and that improves the customer experience for our application. Azure Compute Service is a good place for delivering software on demand. There are a lot of softwares, embedded softwares that we can buy using Azure, and everything on a pay-as-you-go service model. So anytime we need a software, we can go out and immediately buy the software for the next 1 hour or 2 hours, let's say, and use them and then return it back. We're not bound to any yearly licensing cost by that. Azure Computing Services has analytics available for us with which we can analyze, get a good visualization of what's going on in a network, be it logs, be it the performance, be it the metrics. Instead of looking at logs and searching logs and trying to do manual things over the heaps and heaps of logs that we have saved, Azure Analytics Services helps us to get a good visual of what's going on in the network. Where have we dropped? Where have we increased? Or what's causing? What's the major driver? What is the top 10 errors that we get in the server, in the application? Stuff like that. Those can be easily gathered from the Azure Analytic Services. Now, cloud is really a very cool term for the internet. A good analogy would be looking back anytime we look at a diagram. When we do not know how things are transferred, we simply draw a cloud, right? For example, a mail gets sent from a person in one country to a person in the other country. There are a lot of things happening in between from the time you hit the send button and the time the other person hits the read button, right? And the simple and the easiest way of putting it in a picture is simply draw a cloud, and on the one end, one person will be sending the email, and on the other end, the other person will be reading the email. So a cloud is a really cool term for the internet. Now that's some basics about cloud computing. Now that we've understood about cloud computing in general, let's talk about Microsoft Azure as a cloud service. Now, Microsoft Azure is a set of cloud services to build, manage, and deploy applications on a network with the help of Microsoft Azure's frameworks. Now, Microsoft Azure is a computing service created by Microsoft basically for building, testing, deploying, and managing applications and services through a global network of Microsoft managed data centers. Now, Microsoft Azure provides SaaS, which is software as a service, and PaaS, which is platform as a service, and IaaS, infrastructure as a service, and they support many different programming languages, tools, and framework. And those tools and framework include both Microsoft specific and third-party software. Now let me pick and talk about a specific service. For example, management. Azure Automation provides a way for us to automate the manual, long running and frequently repeated tasks that are commonly performed tasks both in cloud and enterprise environment. It saves us a lot of time and increases the reliability, and it kind of gives a good administrative control and even schedules the task automatically to be performed on a regular basis. To give you a quick history of Microsoft Azure, it was launched on 1st February 2010, and it was awarded, or it was called an industry leader for infrastructure and platform as a service by Gartner. Now, Gartner is the world's leading research and advisory company. This Microsoft Azure supports a number of programming languages like C#, Java, and Python. All these cool services we get to use and pay only for how much we use. For example, if we use for an hour, we only get to pay for an hour, even the costliest system available. If we use them for an hour, we only pay for that particular hour, and then we're done. No more billing on the resource that we have used. Microsoft Azure has spread itself more than 50 regions around the world. So it's quite easy for us to pick a region and start provisioning and running our applications probably from day one, because the infrastructure and the tools and technologies needed to run our application are already available. All that we have to do is commit the code in that particular region or build an application and launch it in that particular region, and they become live starting day one. Now, because we have 50 regions around the world, we can very carefully design our environment to provide low latency services to our customers. All right, instead of in traditional data center, let's say, customers will have to, or their request will have to travel all the way around the globe to reach a data center which lives in the other side of the planet. And this adds more latency to it, and it is really not feasible to build a data center near each customer location because of the cost involved. But with Azure, it's possible. Azure already has data centers around the world, and all that we have to do is just pick a data center, build an environment there. They're available starting day one, number one, and also the cost is considerably saved because we are using a public cloud instead of an physical infrastructure to serve those customers from a very local location. And the services that Azure is offering is ever increasing. As of now, as we speak, we have like 200 plus services offered, and they span through different domain or different platform or different technologies available within the Azure console portal. Now, we're going to talk about that later in this section, so hold your breath till we talk about it. But for now, just know that we have like 200 plus services offered by Azure. Let's now talk about different services in Azure, starting with artificial intelligence plus machine learning, where we have a lot of tools and technologies. So the wide variety of services available in Azure includes artificial intelligence plus machine learning plus analytic services to get to give us a good visual of how the data or how the application is performing, or the type of the category of data stored, and to read from the logs. And variety of compute services, different VMs with different size and different operating systems, different containers available, different type of databases available, a lot of developer tools that are available for us, and identity service to manage our users in the Azure cloud. And those users can be integrated or federated with, let's say, Google, Facebook, LinkedIn. So there are some external federation services. They can be used to integrate with our identity system. IoT services, IoT tools and technologies available, and management tools to manage the users. Creating identity is one, and then managing them on top of it is a totally different thing. And we have tools, technologies to manage the users. Cool services for data migration. Data migration is now made simple. Tools and technologies available for mobile application development. And I can plan my own network in the cloud with the networking services. I can implement my own security, both Azure provided and third-party security services on Azure cloud. That's now possible. And a lot of storage options available in the cloud. So these are just a glimpse of the big list of services available in Azure cloud. So that was a glimpse of what's available in the cloud. Let's talk about the services in specific. Let's take compute for example. Whenever we're building a new application or deploying existing ones, the Azure Compute Service provides the infrastructure we need to run and maintain our application. We can easily tap in the capacity that Azure Cloud Service has, and we can scale our compute requirement on demand. We can also containerize our application. We have the option of choosing Windows or Linux VM machine and take the advantage of the flexible options Azure provides for us to migrate our VMs to Azure, and a lot more. And these compute services also include a full-fledged identity solution, meaning integration with Active Directory in the cloud or on-premises, and a lot more. Let's look at some of the services that this compute domain provides. Some of the services the compute domain provides are virtual machines. And this Azure Virtual Machines gives us the ability to develop and manage a virtual computer environment or a virtualized environment inside Azure's cloud environment, that too in a virtual private network. Now we will talk about virtual private network at a later point, but as of now just know that there are a lot of services available in Azure Compute Service that we can get benefited from. We can always choose from a very wide range of compute options. For example, we have an option to choose the operating system. We have the option to choose whether the system should be in on-premises or in the cloud, or do we want to maintain the environment both in on-premises and in the cloud. We have the option of choosing the operating system, whether we want to use our own operating system with some software attached to it, or do we want to go and buy the operating system from the cloud, from Azure Marketplace. And these are just a few of the options available for us when we want to buy the compute environment. And these compute environments are easily scalable, meaning we can easily scale our VM instances from one instance to thousands of virtual machines in a matter of minutes, or simply put, in a couple of button clicks. And all these services are available on a pay for what we use model, meaning there is no upfront cost. We use the service and then pay for the services that we have used. There is no literal long-term commitment when it comes to using virtual machines in the cloud. And most of the services are built on a pay-per-minute billing basis. All right. And at no point, because of the pay-per-minute billing model, at no point we will be overpaying for any of the services. That's attractive, isn't it? Now let's talk about batch service. Now, batch service is always independent. Regardless of whether you choose Windows or Linux, it's going to run fairly well. And with batch service, we can take advantage of the environment's unique features. And not only that, in short, the batch service helps us to manage the whole batch environment, and also it helps to schedule the jobs. Now, this Azure batch service actually runs on a large scale parallel and high performance computing. Because of that, batch jobs are highly efficient in Azure. And when we run batch services, this Azure batch creates a pool of computer nodes and installs the needed applications that we want to run, and then it schedules jobs to those individual nodes in those pools. As a customer, there is no need for us to install a cluster, or there is no need for us to install a software that actually schedules the jobs, or even to manage or even to scale those infrastructure or the software, because everything is managed by Azure. And this batch service is a platform as a service. There is no additional charge for using this batch service, except for, the only charges that we'll be paying is for the virtual machines that the service uses, and the storage that we will be using, of course, and the networking services that we will be using for this batch service. Let's summarize. This batch service, we have a choice of operating system that we can pick and use, and it scales by itself. Now, the alternative for the batch would be queues, but in queues, we'll have to pre-provision and pay for the infrastructure even if we're not using it. But with a batch, we only pay for what we use. And this batch service helps us to manage the application, manage the scheduling as a whole, as if they are just one thing. As next thing in the compute domain, let's talk about this Fabric service. Now, this Fabric service is actually a distributed system platform that helps us to package, deploy, and manage a scalable and a very reliable microservice and containers. And what does it help? This Azure Fabric service helps us, or it helps the developers and administrators so they can avoid the complex infrastructure problems, and they can focus only on implementing workloads or taking care of their development, taking care of their application instead of spending time on infrastructure. So what's Service Fabric? Service Fabric, it provides runtime capabilities and life cycle management to applications that are composed of microservices, no infrastructure management at all. And with Service Fabric, we can easily scale the application to tens or hundreds or even to thousands of machines. Here, machines represent containers. As next thing in compute domain, let's talk about virtual machine scale set. Now, this virtual machine scale set, it lets us to create a group of identical load balanced VMs. I just want to mention it again. It helps us to manage a group identical and load balanced VMs. The number of instances or the number of VM instances in a scale set can increase or decrease in response to the demand or in response to a schedule that we define. The resources needed on a Monday morning is not the same as that would be required on a Saturday or a Sunday morning. All right. And even within the day, the resources that would be needed in the beginning of the business hour is not the resources that would be needed at noon or, after 8 or 9 in the evening. So the demands could actually vary in the environment, and the scale set helps us to take care of the varying demand or take care of the different infrastructure requirement at a different schedule throughout the day, throughout the week, throughout the month, or could be throughout the year as well. The scale set also allows us to provide high availability to our applications, and it helps us to centrally manage, configure, and update a large number of VMs as if they are just one thing. Now you might ask, well, virtual machines are enough. Why would we need a virtual machine scale set? Just like I said, this virtual machine scale set helps us with a greater redundancy and improved performance for our applications. And those applications can be accessed through a load balancer that actually distributes the requests to the application instances. So in a nutshell, this virtual machine scale set, it helps us to create a large number of identical virtual machines, number one. And with scale set, we can increase or decrease the virtual machines. With virtual machine scale set, we can centrally manage and configure and update a big group of VMs. And it's a great use case when it comes to big data or container workloads. As next thing in compute domain, let's talk about cloud services. Now this Azure Cloud Service is actually a platform as a service, and it's very friendly. In fact, it is designed for applications that support scalability or an application that requires scalability or reliability, and on top of it, you want them to be very inexpensive to operate. So Azure Cloud Service provides all these. So where would this cloud service run? Well, it runs on a VM, but it's a platform as a service. VMs are infrastructure as a service, and when we run applications on VM through cloud service, it becomes platform as a service. So here is how you got to be thinking. With infrastructure as a service like VMs, we first create and configure the environment, and then we run applications on top of it. Let's look at the responsibility. The responsibility for us in VM is that we manage everything end to end, like deploying new patches, picking the versions of the operating system, and making sure they are intact and all that stuff. It's all managed by us. But on the contrary, with platform as a service, it's as if the environment is already ready. All that you have to do is deploy your application in it and manage the platform. Manage the platform not as an administrator, because all the administration is taken care by Azure, like deploying new versions of the operating system. It's all handled by the Azure. So we deploy the application and we manage the application. That's it. Infrastructure management is handled by Azure. So what does cloud service provide? This cloud service provides a platform where we can write the application code, and we don't have to worry about hardware. Simply hand over the code and cloud service takes care of it. So no worry on the hardware at all. So responsibilities like patching, what do we do if something crashes? How do I update the infrastructure? How do I manage the maintenance or the downtime in the underlying infrastructure? All that dashboard we can benefit from when we use Azure Cloud Services, and that shows the key statistics all in one place. And we can also set up real-time alerts to warn when a service availability or a certain metrics that we are concerned about degrades. As next thing in compute domain, let's talk about functions. Now functions are serverless computing. Now, many times if you've heard about Azure being serverless, a lot of time they are referencing, or the person who's talking to you is referencing to serverless computing or Azure Functions, which is a serverless computing service hosted on Microsoft Azure. The main motive of a function is to accelerate and simplify application development. Functions helps us to run code on demand without we need to pre-provision or manage any Azure infrastructure. So Azure Functions are script or a piece of code that gets run in response to an event that you want to handle. So in short, we can just write a code that you need for a problem at hand without actually worrying about the whole application or the infrastructure that will be running that code. And the best of all the best is when we use functions, we only pay for the time that our code runs. So what does functions provide, or what does Azure Functions provide? Azure Functions allow users to build applications using serverless simple functions with a programming language of our choice. So the current programming languages that are supported is C#, F#, Node.js, Java, and PHP. So here we really don't have to worry about provisioning or maintaining servers. If a code requires more resource, yes, Azure Functions handles or it provides the additional resources needed by the code. And the best part is we only pay for the amount of time the functions are running, not the resources, but the amount of time the function is running. As next thing, and moving to the new domain, let's talk about the container domain in Azure. Now the container domain or the container service, it allows us to quickly deploy a production ready Kubernetes or a Docker Swarm cluster. Now what's a container? A container is a standard unit of software that packages of code and all its dependencies so the applications run quickly and reliably from one computing environment to another. It could be testing to staging to development environment to staging to production, or from one production to another production, or on-premises to cloud, or one cloud to another cloud, vice versa. Now imagine we had an option not to worry about the VM and just focus on the application. Well, that's exactly what containers helps us achieve. So these container instances enable us to focus on applications and not worrying about managing VMs or not worrying about learning the new tools required to manage the VMs or even the deployment. And our applications that we create, they run in a container. And running in a container is what helps us to achieve all these, not being able to manage or not needing to manage the virtual machines. So these containers, they can be deployed into the cloud using a single command if you're using a command line interface, and a couple of button clicks if we are using the Azure portal. And these containers are kept lightweight, but they are equally secure as virtual machines. Let's talk about container service as next thing. The container service, or sometimes called as Azure Kubernetes Service, it helps us to manage the containers. Container is one thing, and a service that's used to manage the container is another thing. Now this Kubernetes service, or ACS, it helps us to manage the containers. So let's expand on this a bit. So this Azure Container Service, or ACS, it actually provides a way to simplify the creation, configuration, and management of a cluster of virtual machines that are pre-configured to run containerized applications on top of them. Deploying these containers might take like 15 to 20 minutes, or deploying the virtual machines that run containers in it might take 15 to 20 minutes. And once they are provisioned, we can actually manage them by using simple SSH tunnel into them. And this ACS, when it runs applications from Docker images. What does that mean? Docker images makes sure that the applications the container runs are fully portable. Images are portable. And ACS also helps us to orchestrate the container environment. Not only that, it also helps us to ensure that these applications that we run in containers can be scaled to thousands or even tens of thousands of containers. So in a nutshell, managing an existing application into a container and running it using AKS or ACS is really easy, or that's what it is all about, to make the application management or migration easy. Now, managing the container-based architecture, and we discussed that containers could be tens or even tens of thousands of containers. So managing them is made simple using this container services. And even training of model using a large data set in a complex and resource intensive environment, this AKS helps us to simplify that environment. All right, as next thing in container domain, let's talk about container registry. We spoke about registry a little bit when we spoke about Docker images. So container registry is a single place where we can store our images, which are Docker images. When we use containers, it's Docker images that we use for our image purposes. So these container images are a central registry that can be used to ease container development by easing the storage and management of container images. So there we can store all kind of images like Docker Swarm, or the images used in Docker Swarm are in Kubernetes. Everything can be stored in container registry in Azure. Now, anytime we store a container image, it provides us an option for geo replication. What that means is that we can efficiently manage a single registry replicated across multiple regions. Now, these geo replication, it actually enables us to manage global deployments, assuming we are having an environment that requires a global deployment. So it helps us to manage global deployments as one entity because we are geo replicating. We would be updating, we would be editing one image, and that image gets replicated throughout the global replication centers we would have set up. And so just one editing would have actually edited the global images, and those global images would have provisioned the global application. So one edit, replication, and then provisioning of the applications global wide. And this replication also helps us network latency, because anytime an application needs to deploy, it does not have to rely on a single source which can be reached only through high latency network. Because we have global replications around the world, anytime the application wants to check back, it would check back the application which is in a very nearby location for the application itself. Global replication means that we are managing it as a single entity that's being replicated across the multiple regions in the globe. As next thing in our learning, let's talk about Azure databases. Now, this Azure databases are relational. In fact, they have many flavors in them. We're going to look at different flavors, SQL, NoSQL, cache type of database that Azure offers. So we're going to learn one at a time, or we're going to learn one by one. So this Azure SQL database is a relational database. In fact, it's a relational database as a service. It's managed by Azure. We don't get to do a lot of management in it. So it's a relational database as a service based on Microsoft SQL Server database engine. And this database is a high performance database. It's very reliable, and it's very secure as well. And this high reliability, high performance, and for this high security, we really don't have to do anything. It comes along with it, and it's managed by Azure. And there are two things that I definitely need to mention about Azure SQL database. That is, it's an intelligent service. Number one, it's fully managed by Azure, and it also has this one good thing, which is it has built-in intelligence that learns app patterns and adapts to maximize performance and reliability and data protection of the application. That's something that's not found in many of the other cloud providers that I'm aware of. So I thought I'll mention it. So it uses built-in intelligence to learn about the user's database patterns and helps improve performance and protection. And migration or importing data is very easy when it comes to Azure SQL database. So it can be readily or immediately used for analytic reporting and intelligent applications in Azure. As next thing, let's talk about Azure CosmoDB. Now, Azure CosmoDB is a database service that is for NoSQL type, and it's created to provide low latency and an application that scales dynamically or that scales rapidly. Now, this Azure CosmoDB is a globally distributed service, and it's a multi-model database. This can be provisioned in a click of a button. That's all we got to do if we need to provision an Azure Cosmos DB in the Azure. It helps with scaling the database. We can elastically and independently scale throughput and storage across this database and in any of the Azure geographic regions. It provides a good throughput, it provides good latency, it provides good availability, and it provides, or Azure promises, a comprehensive SLA that no other database can offer. That's the best part about Cosmos DB. So this Cosmos DB was built with global distribution in mind, and it's built with the horizontal scale in mind. And all this we can use by only paying for what we have used. And remember, the difference between Azure Cosmos DB and the SQL database is that Azure Cosmos DB supports NoSQL, whereas SQL doesn't. Alright, few other things about Azure Cosmos DB is it allows users to use key value, graph, column, family, and document data. It also gives users a number of API options like SQL, JavaScript, MongoDB, and few others that you might want to check in the document at the time of reading. And the best part here is that all that we mentioned, we get to use only by paying for the amount of storage and throughput that are required. And the storage and the throughput can be elastically scaled based on the requirement of that R. Alright, let's talk about Redis Cache. Discussion about Azure Database won't be complete without we talking about Redis Cache. Now, Redis Cache is a secure data cache. It's also sometimes called as messaging broker that provides high throughput and low latency access to data for the applications. Now, Redis Cache is based on a popular open source caching product, which is Redis, sometimes called as Redis Cache. Now, what's the use case? It's typically used to cache to improve the performance and scalability of a system that rely heavily on backend data stores. Now, performance when we use Redis Cache is improved by temporarily copying the frequently accessed data to a fast storage located very close to the application. Now, with Redis Cache, this fast storage is located in memory with Redis Cache instead of being loaded from the actual disk in the database itself. Now, this Redis Cache can also be used as an in-memory data structure store. Not only that, it can be used as a distributed non-relational database and a message broker. So there are a variety of use cases for this Redis Cache. And by using Redis Cache, the application performance is improved by taking advantage of the low latency and the high throughput performance that this Redis Cache engine provides. So to summarize, this Redis Cache, when we use Redis Cache, data is stored in the memory instead of the disk to ensure that there is high throughput and low latency when the application needs to read the data. It provides various levels of scaling without any downtime or interference. Now, this Redis Cache is actually backed by Redis server, and it supports string, hashes, linked list, and various other data structures. Now let's talk about security and identity services. Now, identity management in specific is a process of authenticating first and then authorizing using security principles. And not only that, identity management involves controlling information about those principal identities. You might ask, now what's a principal identity? Now, identity or principal identity are services, applications, users, groups, and a lot more. The speciality about this identity management is that it not only helps authenticate and authorize principals in cloud, it also helps authenticate and authorize principals or resources on premises, especially when you run an hybrid cloud environment. So all these services and features that this identity management helps us to get additional level of validation, like identity management can provide multi-factor authentication. It can provide access policies based on condition, permit or deny based on condition. It can also monitor suspicious activity. And not only that, it can also report it. It can also help generate alerts for potential security issues, and in a way to mitigate it, can send us an alert so we can get involved and prevent a security accident from happening. So let's talk more about identity management. So some of the services under security and identity management are Azure Security Center. Now, this Azure Security Center provides security management and threat protection across the workloads in both cloud and in the hybrid environment. It helps control user access and application control to stop any malicious activity if present. It helps us to find and fix vulnerabilities before they can be even exploited. It integrates very well with analytic methods that helps us to identify, or it gives us the intelligence to identify or detect attacks and prevent them before it can actually happen. And it also works seamlessly with hybrid environments. So you don't have to have one policy for on-premises and one policy for the cloud. It's now a unified service, both for on-premises and the cloud. The next service in security and identity would be Key Vault. Now, a Key Vault is a service or a feature that helps safeguard the cryptographic keys and any other secrets used by the cloud applications and the services. In other words, this Azure Key Vault is a tool for securely storing and accessing the secrets of the environment, the secret keys. Now, a secret is anything that you really want to have a very tight control access, like the certificates, like the passwords, stuff like that. Now, if I tell you what Key Vault actually solves, that would actually explain what Key Vault is. Now, Key Vault is used in secrets management. It's helped in securely storing the tokens, the passwords, the certificates. It helps in key management. It really helps in creating and controlling the encryption keys that we would use to encrypt data. It helps in certificate management. Talking about certification management, it helps us to easily provision, manage, and deploy public and private SSL, TLS certificates in Azure, and a lot more. So in a nutshell, this Key Vault, it provides users the ability to provision new vaults and keys in just a matter of minutes. All that in a single command, or all that in a couple of button clicks. It also helps users to centrally manage their keys, secrets, and policies. Next in the list, let's talk about Azure Active Directory. Now, Azure Active Directory helps us to create intelligent-driven access policies to limit resource usage and manage user identities. What does that mean? Now, this Azure Active Directory is a cloud-based Active Directory and identity management service. Now, Azure Active Directory combines, it's actually a combination of the core directory services plus application access management plus identity protection. And one good thing about this Azure, in fact, there are a lot of good things, but especially when you're running hybrid environments, you might wonder, well, how this Azure Active Directory is going to behave. Now, this Azure Active Directory is built to work on-premises and cloud environment as well. Not only that, it also works seamlessly with mobile applications as well. So in a nutshell, this Azure Active Directory, it acts as an central point of identity and access management for our cloud environment. It also provides good security solutions that protect against unauthorized access of our app and the data. Now that we've discussed about security and identity, let's talk about the management tools that Azure has to offer. Azure provides built-in management and account governance tools that helps administrators and developers, that helps them to keep their resources secure and very compliant. And again, it helps both in on-premises and in the cloud environment. And these management tools help us to monitor the infrastructure, monitor the applications. It also helps in provisioning and configuring resources. It also helps in updating apps. It helps in analyzing threats, taking backup of the resources, build disaster recoveries. It also helps in applying policies and conditions to automate our environment. We use Azure management tools, and it's also used in cost control methods. So this Azure management plays a wide role across the Azure services. And in the management tools, first comes the Azure Advisor. Now this Azure Advisor, it acts as a guide to educate us about Azure best practices. It throws recommendations that we can select on the basis of the category of service and it also provides the impact it can have, or the impact that would happen in our environment if we follow the recommendations given. And recommendations are, first one is the recommendations are kind of templatized, and it throws the templatized recommendations. Not only that, it also provides customized recommendations on the basis of the configuration, on the basis of our usage patterns. And these recommendations are not hard. It's not like something that it recommends and then just leaves us hanging there. These recommendations provided are very easy to follow, very easy to implement and see results. You can think of Azure Advisor as a very personalized cloud consultant that helps you to follow best practices to optimize our deployments. It kind of analyzes our resources, our configurations, our usage, and then it recommends a solution for us that really helps in improving the cost effectiveness, improving the performance, improving high availability, and improving security in our Azure environment. So with this Azure Advisor, we can get a proactive, actionable, and personalized best practice recommendations. Now, you don't have to be an expert. Just follow the Azure Advisor and your environment is going to be good. It also helps in improve the performance, security, high availability of our environment. And also it helps in bringing down the overall Azure spend. And the best part is it's a free service that analyzes our Azure usage and provides recommendations, how we can optimize our Azure resource to reduce cost. And reduce cost at the same time boost the performance, helps in strengthening the security and improve the overall reliability of our environment. Next in the list would be Network Watcher. Now, this Network Watcher helps users identify and gain insights in the overall network performance and the health of the overall environment. Now, these Azure Watchers provides enough tools to monitor, to diagnose, to view the metrics, and to enable or disable logs, which means generate and collect the logs for resources in the Azure Virtual Network. So with Network Watcher, you can monitor and diagnose issues in networking without even logging into the virtual machines. With just the logs, which are real time, we can actually come to a conclusion what could be wrong in a certain resource, in a VM or in a database, by just looking at the logs. And not only that, it's used for analytic or to gain some intelligence of what's happening in our network. We can gain a lot of insight to the current network traffic pattern using the security group flow logs that this Network Watcher offers. It also helps in investigating VPN connectivity issues using detailed logs. Now, you might or might not know that VPN troubleshooting requires both parties, or it involves two parties. The person, the network administrator on this side and the network administrator on the other side. And they will have to check logs in their end, and we'll have to check logs in our end, stuff like that. But with the Network Watcher, it kind of takes it to the next level. The logs itself, we could easily identify which side is having the issue and suggest an appropriate fix. And the next in the list would be Microsoft Azure Portal. Now, this Microsoft Azure Portal, it provides a single unified console to perform various number of activities like building, not only building, managing and monitoring the web applications that we build. Now, this portal can be used to organize our environment, or the appearance of the environment, or the visual of the environment based on our work style. And using Azure Portal, users can control who gets to manage or access the resources, all from the Azure Portal. And this Azure Portal gives a very good visibility on the spends that happen on each resource, right? And if we can customize it, we can also identify spends based on team, spends based on days, spends based on department, stuff like that. So it kind of gives us a good visual of where the money is spending, or where is the bill consumed within the Azure environment. Next in the list would be Azure Resource Manager. Now, Azure Resource Manager enables us to manage the usage of the application resources. Now, we use Resource Manager to deploy, monitor, and manage solution resources as a group, as if it's one single entity. Now, the infrastructure of our application is typically made of various components, which includes virtual machine, storage, virtual network, web app, database servers, some other third-party services that we might use in our environment. And they are, by nature, separate services. But with Azure Resource Manager, we don't see them as different components or different entities. Instead, we see them as related services in a group that supports an application. Now we kind of get the relation between them instead of letting them spread. Azure Resource Manager identifies the relation between them and helps us to visually see them all as one or single entity. Not only that, Azure Resource Manager helps, or it ensures that the resources that we provision are deployed at a constant rate along with the other application. It also helps users to visually see their resources and how they are connected, and that helps in managing the resources a lot better. Resource group also is used to control who can access the resources within the user's organization. Kind of gives you the fine-grained control over who gets to access and who does not get access. And the last one in the management tools would be automation. And this automation gives us the ability to automate, configure, and install upgrades across hybrid environments. It provides a cloud-based automation and configuration service. Not only that, this can be applied for non-Azure environments as well, which is on-premises. So some of the automation we could do is process automation, update management automation, configuration features automation, stuff like that. And this Azure automation provides complete control during the deployment, operation, and also during the decommissioning of the workloads and resources. With automation, we can actually automate time-consuming or mundane or any task that's error-prone because of human errors. Those things can be automated. So irrespective of how many times you run it, it's going to run the same way. And that really helps in reducing the overall time and also the overhead cost, because a lot of the things are automated, which means it's human error-free, which means the application is not going to break and keep running for a longer time. With automation, we can actually build a good inventory of operating system resources and configuration items all in one place with ease. And this really helps in tracking the changes and investigating the issue. Let's say something happened. Because we have automation, because it's logging the configuration changes, it's easy to track, easy to identify what has changed lately that has broken the environment, go back and fix it or kind of roll it back. That solves the problem. And that actually summarizes the Azure management tools or management services. Now let's talk about the networking tools or the networking services available in Azure. There are a variety of services, especially networking services, that Azure offers, and I'm sure it's going to be an interesting one. Let's begin our discussion with Content Delivery Network. Now, the Content Delivery Network, in short, CDN, it allows us to perform secure and a very reliable content delivery. Not only that, it also helps in accelerating the delivery time, or in other words, reducing the delivery time, also called as load times. It also helps in saving bandwidth and increases in responsiveness to the application. So let's expand on this. The Content Delivery Network is actually a distributed network of servers that can efficiently deliver web content to users. Now, CDNs, we're going to use the word CDN here. CDNs store cached content on global edge servers, also called as POPs, point of presence locations, that are very close to the end users, so the latency is minimized. It's like taking a copy of the data or taking a multiple copy of the data and storing it in different parts of the world, and whoever is requesting it, the data gets delivered to them from a server which is very locally to them. So this CDN offers developers a global solution for rapidly delivering high bandwidth content to users by caching the content in a strategically placed location which is very near to them. So these content delivery networks, it really helps in handling That's one advantage you get for content delivery network. That's we can handle spikes and heavy loads very efficiently. And we can also run analytic against the logs that gets generated in content delivery network, which helps in gaining good insight on the workflow and what would be the future business need for that application. And this, just like a lot of other services, this is on a pay as you go type. So you use the resource first and then you only pay for what you have used. The next one in networking would be ExpressRoute. Now, ExpressRoute is actually a circuit or a link that provides a direct private connection to Azure. And because it's direct, it gives low latency link to Azure. It gives good speed and reliability for the Azure data transfer. It could be on-premises to Azure. So it gives very good speed. It gives increased reliability and low latency for that connection. Let's expand on this a bit. Now, this ExpressRoute is a service that actually provides a private connection between Microsoft data center and infrastructure in our premises or in a different co-location facility that we might have. Now, these ExpressRoutes do not go over the public internet. And because they don't go over the public internet, they offer a high security, reliability, and speed and low latency compared to the connections which are in the internet. Because it's fast, because it's reliable, because it has low latency, it can be used as an extension of our existing data center. Users are not going to feel the difference whether they are accessing services from an on-premises or in the cloud environment, because latency is minimized as much as possible. Users are really not going to see the difference. And because it's a private line and not a public internet line, it can be used to build hybrid applications without compromising privacy or the performance. Now, these virtual private cloud, these ExpressRoutes can be used for taking backups. If assume a backup going through the internet, that would be a nightmare. If we use ExpressRoute for backups, that's going to be fast. And imagine recovering a data through the internet, from the cloud, through the internet, to the on-premises in a time of disaster. That would be the worst nightmare. So these ExpressRoutes can be used not only to backup, but also to recover the data. Because it provides good speed, low latency, recovering the data is going to be a lot sooner. The next product or service we're going to discuss in networking is Azure DNS. Now, Azure DNS allows us to host domain name in Azure, and these domain names come with an exceptional performance and availability. Now, Azure DNS is used to set up and manage DNS zones and records for our domain name in the cloud. Now, this Azure DNS is a service for DNS, just like the name says, and it provides name resolution by using Azure's infrastructure. And by using this domain, we can actually manage the DNS ourselves through the Azure portal with the same credential. Imagine having a DNS provider which does not even belong in our IT. Imagine that environment. We would have a separate portal to manage the DNS environment. Now, those are gone. And now we can actually manage the DNS in the very same Azure portal where we use the rest of the other services. And this Azure DNS very much integrates with other DNS service providers. It uses a global network of name servers to provide fast response to DNS queries. And these domains are having additional availability compared to the other domain service providers' availability promises. These are going to have more availability than the rest because most of the servers are maintained by Microsoft, and it helps resolve sooner. It helps resyncing. Let's say a server fails, it kind of helps resyncing with the rest of the servers. So all the Microsoft's environment, all the Microsoft's global network of name servers kind of ensures that our domain names are resolved properly, not only properly, but also are available most of the time. Right, next in the list in networking services is virtual network. I'm sure this is going to be very interesting and I'm sure you're going to like it. So this networking or virtual networking in Azure, it actually allows us to set up our own private cloud in the public cloud. It gives us an isolated and highly secure environment for our application. Let's expand on this. So this Azure Virtual Network helps us to provision Azure virtual machines, and it helps us to securely communicate with other on-premises and internet networks. It also helps in controlling the traffic that flows through or flows in and out of this virtual network to other virtual networks and to the internet. Now this Azure virtual network, sometimes called as VNet, is actually a representation of our own network in the cloud. It's actually a logical isolation of the Azure cloud dedicated to our subscription. All our environments are provisioned in a VNet that is separate from another customer's VNets. That way we have that logical separation there. So this virtual network can also be used to provision VPNs in the cloud, so we can connect the cloud and the on-premises infrastructure, and a lot more, especially in an environment where we have hybrid environment. Surely we will be using virtual network because that's going to require a VPN for secure data transfer in and out of the cloud and in and out of the on-premises environment. Alright, so it kind of gives us a boundary for all the resources. So all the traffic between the Azure resources, they kind of logically stay in between or logically stay within the Azure virtual network. And here we can design the network. It's given over to us. You can pick the IP, you can pick the routing, you can pick the subnet. A lot of freedom is given, or I would say a lot of control on how the network is designed. It's not like something that's already cooked and we only get to use it. No, we can actually build the network from the scratch. We can pick the IP address that we like. We can pick which subnet needs to communicate with the other subnet, stuff like that. And like I said, if you are using hybrid environment, you definitely would be requiring a virtual network because it helps connect the on-premises and the cloud in a secure fashion using VPN. The last product we're going to discuss in networking is a load balancer. This load balancer actually provides application a good availability and a good network performance. So how does it work? It actually works by load balancing the traffic to and from the virtual machine and the cloud resources. Not only that, it also load balances between cloud and cross-premises virtual networks. With Azure Load Balancer, we can actually scale our application and create high availability for our services, which means our application will be available most of the time. If any of the server goes dead, the server does not get traffic. What happens if the server gets traffic? User is going to experience downtime. What happens if the server does not get traffic? User won't experience any downtime. The connection is shifted to an healthy service, so the user experiences uptime all the time. So this load balancer supports inbound and outbound scenarios, and it provides low latency. It gives high throughput of the data transfer, and we can actually scale up the flow of the TCP and UDP connections from hundreds to thousands to even millions because we have a load balancer now in between the user and the application. So how does it operate? This load balancer actually receives the traffic and it load balances the traffic to the backend pool of instances connected to it according to the rule and the health probe that we set. That's how it maintains high availability. So what does load balancer help? It helps in creation of high available scalable application in the cloud in minutes. It can be used to automatically scale the environment with the increasing application traffic. And one feature of load balancer is to check the health of the user's application instance, and it removes or it stops sending the request to the unhealthy instance and kind of shifts that connection to the healthy instance. That way a user or a connection does not get stuck with an instance that's not healthy. That's all that you need to know about the networking services. Now let's talk about the storage services or the storage domain in Azure. Now Azure Storage in general is a Microsoft managed service provided providing cloud storage, which basically is highly available, secure, durable, scalable, and redundant because it's all managed by Azure. We don't get to manage a lot of it. And these Azure storages are a group of storage services. They cater different needs. And the storage products include Azure Blobs, which is actually an object storage. It includes Azure Data Lake. It includes Azure Files. As you see, it includes Azure Queues. It includes Azure Tables and a lot more. But let's start our discussion with Azure Store Simple. Azure Store Simple is an hybrid cloud storage solution that actually lowers the cost of storage to nearly 60% of how much you would be actually spending without using it. So Azure Simple Storage or Store Simple is an integrated storage solution that manages the storage task between on-premises and the cloud storage. What I really like about Azure is that it's built around a hybrid environment in mind. There are a lot of other cloud providers that are there where running an hybrid environment is a big challenge. It has some compatibility. You won't be able to find an hybrid or a on-premises and cloud solution for your need, stuff like that. But with Azure, especially when it comes to storage, a lot of the things that we're going to see, it clearly is designed with hybrid environment in mind. All right, so let's come back and talk about Store Simple. So Store Simple is an very efficient, cost-effective, and a very easily manageable SAN, storage area networking solution in the cloud. I thought I'll throw in this information. The reason why it got Store Simple is really because it uses Store Simple 8000 series devices which are used in Azure Data Center. And this Store Simple or Simple Storage, it comes along with storage tiering to manage the stored data across the various storage media. So the very current data is actually stored in on-premises on solid state drives, and data that is used less frequently is stored in HDDs or hard disk drives. And the data that requires archived or that needs to be archived, very old data, let's say less frequently used data, candidate for archive, they are actually pushed to the cloud. So you see how this storage tiering automatically happens in Store Simple. And another cool feature of Store Simple is that it enables us to create an on-demand and scheduled backups of data and then store the data locally or in the cloud. And these backups are actually taken in the form of incremental snapshot, which means that they can be created and restored quickly. It's not a complete backup, it's an incremental backup. And these cloud snapshots, they can be critically important when there is a disaster and when there is a disaster recovery scenario, because these snapshots can be called in and they can be put on storage systems and then they become the actual data. So recovering is faster if you have proper scheduled backups or if you have frequent backups. And this Storage Simple, it really helps in easing our backup mechanism, which means it kind of eases our disaster recovery steps or procedures as well. So this Store Simple, it can be used to automate data management, data migration, data movement, data tiering across the enterprise, both in cloud and on premises. It actually improves the compliance and accelerates the disaster recovery for our environment. And if there is one thing that's increasing every new day in our environment, that would be storage. And this Store Simple addresses that need, and we really don't have to pre-plan or think in deep for having a proper storage, because now we have a simple storage available in the cloud, and moreover it's on a pay-as-you-go type. So not much pre-planning on storage is needed. Yes, there will be a need, but not as much as I would without the cloud or without the simple storage. And the next service under storage that we would like to discuss is the Data Lake Store. This Data Lake Store or storage, it's a cost-effective solution for big data analytics in specific. So let's expand this. So this Data Lake Storage is an enterprise-wide repository for big data analytic workload. Now that's the major service that's dependent on this Data Lake Store. And this Data Lake enables us to capture data of any size, of any type, and of any ingestion speed, and it kind of collects them in one single space or in one single place for operational efficiency. And for analytic purpose. Hadoop in Azure is very dependent on this Data Lake Storage. And this a data lake store is designed with performance for analytics in mind. So anytime you think of, or anytime you're using analytic in the cloud, or anytime you're using Hadoop in the cloud in Azure, we are definitely using, or we will be to the most part, or the normal procedure, or the right storage to pick would be data lake store in Azure. It's designed with security in mind. So anytime we use Azure storage, we can be rest assured that we are using storage from within a data center which has, or which was built with security in mind. So this data store also uses Azure Blob storage behind the scenes for global scale, durability, and for performance. Let's talk about blob storage. Now, blob storage provides large amount of storage and scalability. Now, this blob storage is the object storage solution for Azure Cloud. Let's expand a bit on blob storage. Azure Blob Storage is Microsoft offering for object storage. Now, this blob storage is optimized for storing massive amount of unstructured data, which could be text or binary data. It's designed and it's optimized for rapid reads. If I explain to you on what scenarios we would be using blob storage, that might help you get a good understanding of what blob storage is. So it's designed, as of now it's being used in many IT environments to serve images or documents directly to the browser. It helps in storing files for distributed access. A lot of fetchers can fetch data from Azure Blob Storage. And it's currently helping users stream video and audio. It's currently being used for writing log files. It's currently being used to store data as backup and restore at a later point in times of disaster recovery. It also is used as an archiving storage in a lot of cloud IT environments. It's widely used in storing analytic data, not only storing but also running analytic query against the data stored in it. So that's a wide use case for blob storage. Not only that, in addition to all that we mentioned, it also supports versioning. So anytime somebody updates an data, a new version gets created, which means at any point I can roll back as and when needed. And it provides a lot of flexibility on optimizing the user's storage need. It also supports tiering of the data. So based on need, when I actually explore, I would find a lot of options I can pick from that suits to my unique storage environment or unique storage need. And like I said, it stores unstructured data, and this unstructured data is available for customers through REST-based object storage environment. The next product and storage service would be queue storage. Now, queue storage provides durable queues for large volume cloud services. It's a very simple and a cost-effective, durable messaging queue for large workloads. Let's expand this queue storage for a moment. Now, this queue storage is a service for storing large amount of messages that can be accessed from anywhere in the world through HTTP and HTTPS calls. A single queue or a single queue message can be up to like 24 KB in size, and a single queue can contain millions of such 24 KB in size messages. And how much can it hold? It can hold up to the total capacity of the storage account itself. So that's kind of easy to translate. How much would it hold? And this Azure Queue Storage, it provides an messaging solution between applications and components in the cloud. What does it help? It helps in designing an application for scale. It helps in decoupling the application. So, it's not very dependent, or sometimes it's not at all dependent on the other application, because now we have a queue in between which kind of translates, or which kind of connects, or which kind of decouples both the environment. Now we have a queue in between. Both the environment can scale up or scale down independently. The next in the storage service would be file storage. Let's talk about file storage. Now, these Azure files provide secure, simple, and managed cloud file shares. Now, with file share in the cloud, it actually extends the user server's on-premises performance and capacity. and a lot of familiar tools for the cloud file share management can be used along with the file storage that we're talking about. So let's expand a bit on file storage. Now this Azure Files or Azure File Storage offers a fully managed file shares in the cloud that can be accessed via the SMB protocol, Server Message Block Protocol. Now this Azure file shares can be mounted concurrently by cloud or in on-premises deployments. A lot of operating systems are compatible with it. Windows are compatible, Linux is compatible, Mac OS is compatible. In addition to all this being able to run on-premises and on the cloud, or being able to access from on-premises and on the cloud, it can also offer cache for caching the data and keeping it locally so it's immediately available when needed. So that's some additional feature. I would say that's some advanced feature that it offers compared to the other file shares available in the market. Let's talk about table storage. Now, table storage is a NoSQL key value pair storage for quick deployments with large semi-structured data sets. The difference between one important thing to note with table storage is that it has a flexible data schema and also it's highly available. Let's expand a bit on table storage. So anytime you want to pick a schema-less a NoSQL type table storage is the one we'll end up picking. It provides an key pair attribute storage with a schema-less design. This table storage is very fast and very cost effective for many of the applications, and for the same amount of data it's a lot cheaper when you compare it with the traditional SQL data or data storage. So some of the things that we can store in the table storage are, of course, they're going to be flexible data sheets such as user data for web application, address books, device information, and other types of metadata for our service requirements. And it can have any number of tables up to the capacity limit of the storage account. Now this is not possible with SQL. This is only possible with NoSQL, especially with table storage in Azure. Explanation of storage really concluded the length and breadth of the explanation this CEO was giving his IT personnel. But this IT personnel is not done with it yet. He still has a question even after this lengthy discussion, and his question was, well, there are a lot of other cloud providers available. What made you specifically choose Azure? I mean, from the kind of question that he asked, we can say that he is very curious, and he definitely had asked a very thoughtful question. So his CEO went on and started to explain about the other capabilities of Azure, or how it kind of outruns the rest of the cloud providers. So he started, or he again started his discussion, but from a different angle now. So he started to explain what are the capabilities or how Azure is better than the competitors. So he started with explaining the platform as a service capabilities. And I'm going to tell you what the CEO told his IT person. So this platform as a service, or in platform as a service, the infrastructure management is completely taken care by Microsoft, allowing users to focus completely on the innovation. No more infrastructure management responsibilities. Go and focus on innovation. That's a fancy way of saying it. When we buy platform as a service, that's what we get. We can contribute our time on innovation and not just maintaining the infrastructure. And Azure especially is .NET friendly. Azure supports the .NET programming language, and it has, or it is built or designed, or it is optimized to work with old and new applications deployed using .NET programming framework. So if your application is .NET, most of the time you would end up picking Azure. I mean, if you try to compare, most of the time you would end up picking Azure as your cloud service provider. And the security offerings that Azure offers is it's designed based on the security development lifecycle, which is an industry-leading assurance process. When we buy services from Azure, it assures that the environment is designed based on security development lifecycle. And like I mentioned many times in the past, and I would like to mention it again, Azure has well thought about the hybrid environments. which a lot of other cloud providers have failed. So it's very easy to set up an hybrid environment, to migrate the data or not to migrate the data and still run a hybrid environment. They work seamlessly with Azure, because Azure provides seamless connection across on-premises data centers and the public cloud. It also has a very gentle learning curve. If you look at the documentation, it's picture rich, and the documentations are neat and clear. It would encourage you to learn more. It would encourage you to think and imagine and try easily get a grasp of how services work. So it has a very gentle learning curve. Azure allows the utilization of technologies that several businesses have used for years. So there is a big history behind it. It has a very gentle learning curve. The certifications, the documentations, the stage-by-stage certification levels, it's all very gentle learning curve, which is generally missing in other cloud service providers. Now, this would really impress the CTOs or people working in finance and budgeting. If an organization is already using Microsoft software, they can definitely go and avail or be bold and ask for a discount that can reduce the overall Azure spending. In other words, overall pricing of the Azure. So that's what helped, or they are the information that helped the CEO pick Azure as his cloud service provider. And then the CEO goes on and talks about the different companies that are currently using Azure, and they are definitely using Azure for a reason, like Pixar, Boeing, Samsung, EasyJet, Xerox, BMW, 3M. They are major multinational, multi-billion companies. They rely, run, operate their IT in Azure. And this CEO has a thought that his IT person is still not very convinced unless and until he shows him a visual of how easy things are in Azure. So he goes on and explains about a practical application of Azure, which is what exactly I'm going to show you as well. All right, a quick project on building an Azure app using, or building a .NET application in Azure Web App and making it connect to an SQL database will solidify all the knowledge that we have gained so far. So this is what we're going to do. I have an Azure account open, as you see, logged in, and everything is fresh here. Let me go to resource group. There's nothing in there. It's kind of fresh. All right, I'm logged in, and this is what we're going to do. So we're going to create an application like this, which is nothing but an to-do application, a to-do list application, which is going to run from the web app, get information from us, and save it in the database that's connected to it. So you can already see it's a two-tier application, web and DB. All right. So let me go back to my Azure account. The first thing is to create an resource group. Let's give it a meaningful name. Let's call it Azure Simplilearn. All right. And it's going to be a free trial. And the location, pick one that's nearest to you, or wherever you want to launch your application. Now for this use case, I'm going to pick Central US and create. It's going to take a while to get created. There you go. It's created. It's called Azure Simplilearn. Now what do we need? We need an web app and a separate SQL database. Let's first get our web app running. So go to App Services and then click on Add. It's not the web app plus SQL that we want. We want web app alone for this example. So let's create an web app. Give it a quick name. Let's call it Azure Simplilearn. The subscription is free trial. And I'm going to use my existing resource group, a resource group that we created some time back. It's going to run out of Windows, and we're going to publish the code. All set, we can create it. All right, while this is running, let me create my database. All right, SQL database, create a database. Give it a name. Let's call it Azure Simplilearn DB. Put it in our existing resource group that we created. It's going to be a blank database, all right? And it's going to require some settings, like the name of the server and the admin login, the password that goes along, and in which location this is going to be created. The server name is going to be Azure Simplilearn DB. That's the server name. And the admin login can be, what can be the admin login name? Let's see. So let's call it Simplilearn. That's my admin login name. And let me pick a password. Click on create. So what have we done so far? We have created an web app and we have created a database in the resource group that we have created. So if I go to resource group, it's going to take some time before things show up. So if I go to my resource group, I only have one resource group as of now, Azure Simplilearn, and there I have a bunch of resources being created. It's still being created. Right. In the meantime, I have my application right here that's running out of or that's in Visual Studio as of now. Right. So once the infrastructure is set and ready in the Azure console, we're going to go back to Visual Studio, feed these inputs in the Visual Studio so the code knows what the database is, the credentials to log into the database, stuff like that. So we're going to feed those information in Visual Studio. By that, we're actually feeding it into the application, and then we're going to run it from there. Deploying these applications takes quite a while. We really got to be patient. Right, now we have all the resources that we need for the application to run. Here's my database, and here's my app service. There's one more thing we need to do, that is create an firewall exception rule. So one more thing needed is to create an firewall exception rule, right? So the application is going to run from my local desktop, and it's going to connect to the database, right? So let's add an exception rule by simply adding the client IP. It's going to pick my IP, the IP of the laptop I'm using as of now, and it's going to create an exception to access the database. So that's done. Now we can go back to our Visual Studio. I already have a couple of apps running, or a couple of configurations pushed from Visual Studio. I'm going to clean that up. If you're doing it for the first time, you may not need to do this. Alright, so let's start from the scratch. This is very similar to how you would be doing in your environment. Alright, so we're going to select an existing Azure app service. Now before that, I have logged in. As you can see, I have logged in with my credentials. So it's going to pull few things automatically from my Azure account. So in this case, I'm going to use an existing Azure app. So select existing and then click on publish. Alright, if you recall, these are the very same resources that we created a while back. Right, we have clicked on save, and it's running, kind of validating the code, and it's going to come up with an URL. Now initially the URL is not going to work because we haven't mapped the application to the database. So that would be the next thing. Alright, so the app has been published and it's running from my web app as of now. It's going to throw an error. Like you see, it's throwing an error. That's because we haven't mapped the app and the DB together. So let's do that. Alright, let's do that. So let's go to Server Explorer. This is where we're going to see our databases that we have created. Now let's quickly verify that. Go back to the resource group, right? Appropriate resource group, which is right here. And here I have my database, Azure Simplilearn database. Right, it has some issues connecting to my database. Give me a quick moment. Let's fix it. All right, so we'll have to map the database into this application. All right, so let's go to the Solution Explorer, click on Publish, and a page like this gets shown. And from here, we can go to Configure. Here is our web app, all right, with all its credentials. Let's validate the connection, number 1. All right, and then click on Next. This is my DB connection string, right, which the app is going to use to connect to my DB. Now, if you recall, our DB was Azure Simplilearn DB, and that's not being shown here. So let's fix that. Right, so let's fix that. Click on Configure, and here let's put our DB servers URL. Now before that, let's change this to SQL Server. All right, and then in here put the DB's URL. So go back to Azure. Here is my DB or server's name. Put that here. Right, the username to connect to the server, that's right here. Put that in, and the password to connect to the server, let's put that in. All right, it's trying to connect to our Azure portal or the Azure infrastructure, and here is my database. If you recall, it's Azure SLDB. That's the name of the database. Let's test the connection. Connection is good. Click on OK. So now it's showing up correctly. Azure Simplilearn DB, that's the name of the database that we created. Now it's configured. All right, let's modify the data connections. Right, let's map it to the appropriate database again. All right, so our name of the database is Azure Simplilearn DB, and then it's going to be SQL Server. That's the data source. The username is Simplilearn, and the password is what we have given in the beginning. All right, let's validate the connection. It's good. Click OK. Now we're all set and ready to publish our application again. Now the application knows how to connect to the database. We have educated it with the correct connection strings, the DNS name, the username, and the password for the application to connect to the database. So Visual Studio is building this project, and once it is up and running, we'll be prompted with an URL to connect, and anytime we put or we give inputs to the URL, that's going to receive the input and save it in the database. Alright, so here is my to-do list app, and I can start creating to-do list for myself. All right, so I have the items already listed. I can create an entry, and these entries get stored in the database. I can create another entry. Take the dog for a walk. That's gonna get stored. I can create another entry. Book tickets for a scientific exhibition, and that's going to receive and put that in the database. And that concludes our session. So through this session we saw how I can use Azure Services to create a web app and connect that to the DB instance, and how those two services which are decoupled by default, which are separate by default, how I can use the connection strings to make connection between the app server and the database and be able to create an working app. I strongly believe you enjoyed me walking you through this session.
Let's ask the question, what is Microsoft Azure? Microsoft Azure is actually a cloud service platform that allows users to build, manage, scale and deploy applications by giving them access to cloud services. Now, these cloud services range from creating virtual machines to creating functions that run themselves without having to worry about hardware. Now, all of this is made possible only through the internet. Now, here are some things that you need to know about Azure. Firstly, it was launched on the 1st of February 2010. It has data centers in more than 42 regions across the world. They also say that 12 more data centers are in the making, which helps them say they're the only cloud service provider that covers these many regions. Next, Azure is preferred by 80% of the Fortune 500 companies, which means that the best of the best in the market only choose to work with Azure. And finally, Azure is the second largest cloud service provider in the market right now. Let's talk about Azure Services. As I told you, Azure provides services for a wide range of domains. Now let's have a look at some of these domains. There's AI and machine learning, compute, containers, database, identity, management tools, networking, security, storage, and so much more. Now let's have a look at some of the individual services within these domains. Firstly, you have Azure Virtual Machines. With Azure Virtual Machines, what you get is the opportunity to create Windows or Linux virtual machines. Now all of this is possible in a matter of seconds with a large amount of customization. Now let's have a look at some of its features. Firstly, you can choose from a wide variety of virtual machine options. Then you have a large amount of optimization available to you. For example, what size of operating system do you want? How much size do you want allocated to it? What version of the system is it? And so much more. Then it provides low cost and per minute billing. Now Azure provides you per minute billing, which means that you're only charged for how much time you use the service. And finally, you have enhanced security and protection for your virtual machines. Next, we have Service Fabric. Now with Service Fabric, you have a platform which enables you to create microservices. Now this also makes the process of application lifecycle management a whole lot easier. As a direct result, you can create applications with a faster time to market. It supports Windows, Linux, on-premises or other clouds, and it enables you to do a tremendous amount of scaling up depending on your requirement. And finally, we have functions. Now with functions, you can build applications with the help of serverless computing. Here, the users only pay for the amount of resources that they've used. You can create applications in any language that you want. And the only thing you need to worry about is the code of the application. Everything other than that, that is the hardware requirements, are taken care of by Azure. Now let's have a look at the networking services. Firstly, we have the Azure CDN, or the Content Delivery Network. With Azure CDN, what you get is the ability to deliver your content with reduced load times, fast responsiveness, and less bandwidth. Now, CDN can be integrated with several other Azure services so that the process can move at a faster rate. It can handle heavy loads and traffic spikes with ease. It also provides a robust security system. Now, with the content that's delivered, you can get advanced analytic data with which you can understand how customers are using your content. Next, we have ExpressRoute. With ExpressRoute, you can connect your on-premises network to Azure through a private network. Now, by default, this lowers latency. It increases the emphasis on reliability and speed, and it can be of great use when you have to transfer large amounts of data between networks. Now, another way this can be useful is if it's used to add compute or storage capacity to data centers. Next, we have Azure DNS. Domain Name Service, or Azure DNS, can be used to host your domains on Azure. This provides high availability and great performance. It provides fast responses to DNS queries by taking advantage of Microsoft's global network. It also provides high availability. Next, we have virtual network. Azure Virtual Network allows the Azure resources to communicate with each other or other on-premise networks via the internet, and all of this is kept extremely secure. Now with this, users can create their own private network for communication. It provides users with an isolated and extremely secure environment for their applications to run. Now all of the traffic stays entirely within the Azure network, and it also allows users to design their own networks. Next, we have Traffic Manager. Now with Traffic Manager, you can route incoming traffic to improve your performance and availability. Now one thing it provides is multiple failover options. So if a particular situation goes wrong, there's always an option to consider to salvage the situation. It helps reduce application runtime and enables the distribution of user traffic across multiple locations. It also helps the people who are using it to know where the customers connecting from across the world. Next, we have Load Balancer. With this, you are provided the ability to instantly scale applications at the same time providing high availability and improved network performance for users' applications. It can be integrated into virtual machines and cloud services. It provides highly reliable applications. It also allows users to secure and integrate security groups. Finally, we have Azure VPN Gateway. Now this allows users to connect their on-premise networks to Azure using a site-to-site VPN. Now this allows users to connect their virtual machine to anywhere in the world through a point-to-site VPN. And also it's very easy to manage and is highly available. Now let's talk about the storage services. First, we have Data Lake Storage. Now with this, what you get is a scalable data storage with an emphasis on cost effectiveness and scalability. Now it comes of maximum use when you integrate it with other services so that you can get analytics on how the data is being used. It is also integrated with other services like the Azure Blob Storage. Now it is also optimized for big data analysis tools like Apache Spark and Hadoop. Next up, we have Blob Storage. Now Blob Storage provides a storage capacity for data. Now depending on how often a particular data is used, it is classified into different tiers. Now all the data that is within the Blob Storage is unstructured data. Now it has a way of ensuring that the data integrity is maintained every time a particular object is being changed or the data is being accessed. And it also helps improve app performance and reduces bandwidth consumption. Next, we have Queue Storage. Now with this, you have a message queuing system for large workloads. This allows users to build flexible applications and separate functions. Not to mention, with this, you can be sure that your individual components will not fail. It also makes sure that your application is scalable. Queue Storage provides queue monitoring, which helps ensure that the customer's demands are met. Then we have File Storage. Now with File Storage, you can perform file sharing with the help of the SMB protocol or the Server Message Block Protocol. Now this data is protected by SMB 3.0 and the HTTPS protocol. In this case, like we mentioned in functions, Azure takes care of all the hardware needs and the operating system deployments on its own. It also improves on-premises performance and other capabilities. Lastly, we have Table Storage. With Table Storage, you can deploy semi-structured datasets and a NoSQL key value store. Now this is used for creating applications which have a flexible data schema, and also considering how it has a very strong consistency model, it's mainly aimed for enterprises. Next, let's have a look at some web and mobile services. First, we have the Azure Search. Now with Azure Search, you get a cloud search service which is powered by artificial intelligence. With this, you can develop web applications as well as mobile applications. Now one big advantage is that you don't have to set up or manage your search indices. Azure takes care of that. And by extension, it increases your development speed. The artificial intelligence also will provide insights and structured information that you can use to improve the search and structured information. Next, we have Logic Apps. Now with this, you can create integration solutions which can connect applications that are important to your business. Now with this, you can visually create business processes and workflows. You can integrate SaaS or software as a service applications and enterprise applications. And more importantly, it allows you to unlock data within a firewall and securely connect to services. Next, we have web applications. Now with web apps, you can create, deploy, and scale web applications according to business requirements. Now it supports both Windows and Linux platforms, and it helps with continuous integration or deployment abilities. Another very important aspect of this is that the data can be deployed and hosted across multiple locations in the world. And finally, we have mobile apps. With mobile apps, you can create applications for iOS, Android, and Windows platforms. One advantage is that it automatically scales up and down based on your requirements. Now, in situations where you have network issues, offline data syncing ensures that your applications work anyway, and you can create cross-platform applications or native applications for iOS, Android, and Windows. Next, let's have a look at some container services. First, let's talk about ACS or Azure Container Services. It is also known as the Azure Kubernetes Services, as it's a fully managed Kubernetes container orchestration service. Now, what this means is that it eases the process of container integration and deployment. It also can be used with other resources from security like virtual networks, cryptographic keys, and so much more to ensure that your container is kept secure. Next, we have container instances. Now, this is similar to functions in a way, just that in this we're using containers without having to manage servers. Now, applications can be developed here without managing virtual machines or learning new tools. All that is Azure's problem to take care of. And it enables building applications without having to manage the infrastructure. That is, all you need to worry about is running the container. Next, let's have a look at some database services. First, we have the SQL database. Now, with SQL database, what you get is a relational cloud database service. Now, this means that it helps accelerate your app development and makes it easier for you to maintain your application. Now, SQL database is also used extensively in migrating workloads to the cloud, and hence saves time and cost. It also helps improve your performance by integrating machine learning and adaptive technologies into your database. Next, we have Azure Cosmos DB. Now, this is a globally distributed multi-model database service. Now, what this means is that with this, you can create applications which support NoSQL. It provides a high-grade security system, has high availability and low latency. Now, this is usually used in situations where you have a diverse and highly unpredictable workload. Now, let's have a look at some security and identity services. Firstly, we have the Azure Active Directory. Now, if you want to know more about Azure Active Directory, I suggest you click on the top right corner and watch our video on the Azure Active Directory. This is just an introduction. So with this, you can manage user identities and you can make sure the resources are kept safe with the help of access policies. Most of these are intelligence driven. Now, one of the main features is that you can have access to your applications from any location or device. It helps increase your efficiency and helps down cutting costs when it comes to having a help desk. It can also help improve security and can respond to advanced threats in real time. Next, you have Azure Active Directory B2C. It helps provide customer identity and access management in the cloud. Now, protecting customer identity is extremely important for an organization, and that's what Azure AD B2C does. Now, it also enables the application to be scaled to great amounts, even billions of customers. Next, we have the Azure Security Center. This is basically like a command post with which you get a complete view of the security across users on your on-premises and cloud workloads. So with this, you are given a threat protection method that adapts to situations and helps reduce exposing you to threats. It also has rapid threat response and makes the process of finding and fixing vulnerabilities a whole lot easier. Next up, let's talk about monitoring and management services. So first, let's have a look at Azure Advisor. Now, Azure Advisor is basically a guide for the best practices when it comes to Azure. Now, when you follow these, it improves performance, security, cost, and increases availability. Now, it also learns from how you use the services on your configuration and usage pattern, and the adjustments that it suggests can be implemented very quickly and easily. Next, we have Network Watcher. Now, with this, you can monitor, diagnose, and understand the working of your network. Now, you can monitor your network without actually having to log in to your virtual machine. Now, you can also use something known as network security flow logs to understand the traffic pattern, how much traffic is coming towards you, how much you're giving, and so much more. It also helps diagnose VPN problems that you might have with detailed logs. And finally, you have the Azure Resource Manager. Now, with this, you can ensure that the resources that you have are managed and deployed at a consistent rate. Now, this makes it extremely easy for you to manage and visualize your resources that are used in your applications or some other requirements, and you can control who can access your resources as well as perform actions on it. Today, I'm joined by two giants of the cloud computing industry. They'll be going head to head with each other to decide who amongst them is better. It's going to be one hell of a fight. Now, let's meet our candidates. On my left, we have AWS, who's voiced by Apeksha.
Hi guys.
And on my right, we have Microsoft Azure, who's voiced by Anjali.
Hey there.
So today, we'll be deciding who's better on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, free tier, and instance configuration. Now, let's listen to their opening statements. Let's start with AWS.
Launched in 2006, AWS is one of the most commonly used cloud computing platforms across the world. Companies like Adobe, Netflix, Airbnb, HTC, Pinterest, and Spotify have put their faith in AWS for their proper functioning. It also dominates the cloud computing domain with almost 40% of the entire market share. So far, nobody's even gotten close to beating that number. AWS also provides a wide range of services that covers a great number of domains. Domains like compute, networking, storage, migration, and so much more.
Now, let's see what Azure has to say about that.
Azure was launched in 2010 and is trusted by almost 80% of all Fortune 500 companies. The best of the best companies in the world choose to work only with Azure. Azure also provides its services to more regions than any other cloud service provider in the world. Azure covers 42 regions already, and 12 more are being planned to be made. Azure also provides more than 100 services spanning a variety of domains.
Now that the opening statements are done, let's have a look at the current market status of each of our competitors. This is the performance round. Here we have the stats for the market share of AWS, Azure, and other cloud service providers. This is for the early 2018 period. Amazon Web Services takes up a whopping 40% of the market share, closely followed by Azure at 30% and other cloud services adding 30%.
This 40% indicates most organizations' clear interest in using AWS. We are number one because of our years of experience and trust we've created among our users.
Sure, you're the market leader, but we are not very far behind. Let me remind you, more than 80% of the Fortune 500 companies trust Azure with their cloud computing needs. So it's only a matter of time before Azure takes the lead.
The rest of the 30% that is in AWS or Azure accounts to the other cloud service providers like Google Cloud Platform, Rackspace, IBM SoftLayer, and so on. Now for our next round, the comparison round. First, we'll be comparing pricing. We'll be looking at the cost of a very basic instance, which is a virtual machine of 2 virtual CPUs and 8 GBs of RAM. For AWS, this will cost you approximately $0.0928 per hour. And for the same instance in Azure, it'll cost you approximately $0.096 per hour. Next up, let's compare market share and options.
As I mentioned before, AWS is the undisputed market leader when it comes to the cloud computing domain, taking up 40% of the market share. By 2020, AWS is also expected to produce twice its current revenue, which comes close to $44 billion. Not to mention, AWS is constantly expanding its already strong roster of more than 100 services to fulfill the shifting business requirements of organizations.
All that is great, really, good for you. But the research company Gartner has released a magic quadrant that you have to see. You see, the competition is now neck to neck between Azure and AWS. It's only a matter of time before Azure can increase from its 30% market share and surpass AWS. This becomes more likely considering how all companies are migrating from AWS to Azure to help satisfy their business needs. Azure is not far behind AWS when this comes to services as well. Azure's service offerings are constantly updated and improved on to help users satisfy their cloud computing requirements.
Now, let's compare AWS and Azure's free offerings.
AWS provides a significant number of its services for free, helping users get hands-on experience with the platform, products, and services. The free tier services fall under 2 categories: services that will remain free forever and the others that are valid only for 1 year. The always free category offers more than 20 services, for example Amazon SNS, SQS, CloudWatch, etc. And the valid for a year category offers approximately 20 services, for example Amazon S3, EC2, Elasticache, etc. Both types of services have limits on their usage, for example storage, number of requests, compute time, etc. But users are only charged for using services that fall under the valid for a year category after a year of their usage.
Azure provides a free tier as well. It also provides services that belong to the categories of free for a year and always free. There are about 25 plus always free services provided by Azure. These include App Service, Functions, Container Service, Active Directory, and lots more. And as of the valid for a year, there are 8 services offered. There's Linux or Windows virtual machines, blob storage, SQL database, and few more. Azure also provides the users with credits of $200 to access all their services for 30 days. Now, this is a unique feature that Azure provides, where its users can use their credits to utilize any service of a choice for the entire month.
Now, let's compare instance configuration. The largest instance that AWS offers is that of a whopping 256 GBs of RAM and 16 virtual CPUs. The largest that Azure offers isn't very far behind either, 224 GBs of RAM and 16 virtual CPUs. And now for the final round. Now each of our contestants will be shown facts and they have to give explanations for these facts. We call it the rapid fire round. First, we have features in which AWS is good and Azure is better.
AWS does not cut down on the features it offers its users. However, it requires slightly more management on the user's part.
Azure goes slightly deeper with the services that fall under certain categories like Platform as a Service and Infrastructure as a Service.
Next, we have hybrid cloud, where AWS is good and Azure is better.
Okay, although AWS did not emphasize on hybrid cloud earlier, they are focusing more on technology now.
Azure has always emphasized on hybrid cloud and has features supporting it since the days of its inception.
For developers, AWS is better and Azure is good.
Of course it's better, because AWS supports integration with third-party applications.
Well, Azure provides access to data centers that provide a scalable architecture.
For pricing, both AWS and Azure are at the same level.
It's good for AWS because it provides a competitive and constantly decreasing pricing model.
And in the case of Azure, it provides offers that are constantly experimented upon to provide its users with the best experience.
And that's it. Our contestants have finished giving their statements. Now, let's see who won. Surprisingly, nobody. Each cloud computing platform has its own pros and cons. Choosing the right one is based entirely on your organization's requirements.
A small software development firm, and you want to scale your business up. However, a small team size, the unpredictability of demand, and limited resources are roadblocks for this expansion. That's when you hear about cloud computing. But before investing money into it, you decide to draw up the differences between on-premise and cloud-based computing to make a better decision. When it comes to scalability, you pay more for an on-premise setup and get lesser options too. Once you've scaled up, it is difficult to scale down and often leads to heavy losses in terms of infrastructure and maintenance costs. Cloud computing, on the other hand, allows you to pay only for how much you use, with much easier and faster provisions for scaling up or down. Next, let's talk about server storage. On-premise systems need a lot of space for their servers, notwithstanding the power and maintenance hassles that come with them. On the other hand, cloud computing solutions are offered by cloud service providers who manage and maintain the servers, saving you both money and space. Then we have data security. On-premise systems offer less data security, thanks to a complicated combination of physical and traditional IT security measures, whereas cloud computing systems offer much better security and lets you avoid having to constantly monitor and manage security protocols. In the event that a data loss does occur, the chance for data recovery with on-premise setups are very small. In contrast, cloud computing systems have robust disaster recovery measures in place to ensure faster and easier data recovery. Finally, we have maintenance. On-premises systems also require additional teams for hardware and software maintenance, loading up the costs by a considerable degree. Cloud computing systems, on the other hand, are maintained by the cloud service providers, reducing your costs and resource allocation substantially. So now, thinking that cloud computing is a better option, you decide to take a closer look at what exactly cloud computing is. Cloud computing refers to the delivery of on-demand computing services over the internet on a pay-as-you-go basis. In simpler words, rather than managing files and services on a local storage device, you'll be doing the same over the internet in a cost-efficient manner. Cloud computing has two types of models: deployment model, and service model. There are 3 types of deployment models: public, private, and hybrid cloud. Imagine you're traveling to work. You've got 3 options to choose from. 1. You have buses, which represent public clouds. In this case, the cloud infrastructure is available to the public over the internet. These are owned by cloud service providers. 2. Then you have the option of using your own car. This represents the private cloud. With the private cloud, the cloud infrastructure is exclusively operated by a single organization. This can be managed by the organization or a third party. And finally, you have the option to hail a cab. This represents the hybrid cloud. A hybrid cloud is a combination of the functionalities of both public and private clouds. Next, let's have a look at the service models. There are 3 major service models available: IaaS, PaaS, and SaaS. Compared to on-premise models, where you'll need to manage and maintain every component, including applications data, virtualization, and middleware, cloud computing service models are hassle-free. IaaS refers to infrastructure as a service. It is a cloud service model where users get access to basic computing infrastructure. They are commonly used by IT administrators. If your organization requires resources like storage or virtual machines, IaaS is the model for you. You'll only have to manage the data, runtime, middleware, applications, and the OS, while the rest is handled by the cloud providers. Next, we have PaaS. PaaS, or Platform as a Service, provides cloud platforms and runtime environments for developing, testing, and managing applications. This service model enables users to deploy applications without the need to acquire, manage, and maintain the related architecture. If your organization is in need of a platform for creating software applications, PaaS is the model for you. PaaS only requires you to handle the applications and the data. The rest of the components like runtime, middleware, operating systems, servers, storage, and others are handled by the cloud service providers. And finally, we have SaaS. SaaS, or Software as a Service, involves cloud services for hosting and managing your software applications. Software and hardware requirements are satisfied by the vendors, so you don't have to manage any of those aspects of the solution. If you'd rather not worry about the hassles of owning any IT equipment, the SaaS model would be the one to go with. With SaaS, the cloud service provider handles all components of the solution required by the organization. Time for a quiz now. In which of the following deployment models are you, as the business, responsible for the application, data, and operating system? 1. IaaS. 2. PaaS. 3. SaaS. 4. IaaS and PaaS. Let us know your answer in the comment section below.
In this session, we learn about Google Cloud Platform, wherein we will learn about what is cloud computing, why Google Cloud Platform, what is GCP, that is Google Cloud Platform domains, about a use case, that is Ferrero use case, and also a quick demo on using services from Google Cloud Platform. So when we talk about Google Cloud Platform, we also need to know what is cloud computing. So cloud computing is the use of hardware and software components to deliver a service to a network. Users can access these files and applications and services provided by a cloud provider from any device that has access to internet. In short, cloud computing is a way where cloud provider provides access to different services such as resources. And when we talk about resources here, we talk about computing, we talk about memory, we talk about processing power, we talk about storage, and we also talk about different services which cloud providers make available for the users. Now that allows us for automatic software integration, backup and restoring data, unlimited storage capacity, having a reliable use of different services, and having a cost-efficient solution. Now, we know that cloud computing's models, there are different service models. So you have platform as a service, you have infrastructure as a service, and you have software as a service. And these are the prominent models which are offered by different cloud providers such as Google Cloud, such as Google, you have Amazon, you have Azure, and also some organizations build their own private clouds using open source OpenStack. Let's focus more on Google Cloud Platform and what it has to offer and how it is gaining popularity in the market with different organizations which would want to work on a cloud platform or which would want to work on an infrastructure which is modernized. So when we talk about cloud computing, this is one of the approach which organizations can take to instantaneously benefit from modernization using different services, different platforms, and also newer technologies for their various requirements such as scalability or dynamic businesses. Before we get into Google Cloud Platform, it is also good to understand where you can find some useful resources about Google Cloud Platform. And here you have a website which is from your Google Cloud. So this is cloudacademy.com/library/Google. And here you can create a free account. Now that would give you just 7 days trial, but that has a lot of videos which talk about your Google Cloud Platform and essentials, and it has various certification related videos which you can access. And then after 7 days after you have tried, you can obviously go for a paid account where you can take detailed learning from here. Now this is your training library which shows your different cloud providers such as Amazon, Microsoft Azure, GCP, and then you have various other topics which are specifics to organization. You can obviously look at the pricing, and you can also look at resources which will give you a good experience in learning from these videos. You can also create a free account, which I will walk you through later. So you can create a free account on cloud.google.com. Now, when I say free account, that basically means it allows you to create an account, and every user who creates an account gets a $300 free credit, which can be used to practice, brush up your skills, and also explore and learn about different Google Cloud products which are offered by Google. Now, coming back to our Google Cloud Platform, let's understand why Google Cloud Platform. So Google Cloud Platform is popular for many reasons. Now let us see a few of most important reasons why it stands out. When you talk about pricing, pricing is one of the significant factors that make Google Cloud stand out among the other cloud providers. It offers a monthly pricing plan, which is billed according to monthly usage. And when we talk about billing here, the billing can be in hours, it can be in minutes, and it can also be in seconds. There are different options when you talk about your pricing, which can be found from your Google Cloud webpage. Now, pricing could be based on preemptive machines. Pricing could be based on reserved instances or reserved resources. I'll show you the link where you can find more details on pricing part of it. So Google Cloud really has various pricing options which help customers in their different requirements, whether they would go for any of the service models such as infrastructure as a service, platform as a service, or even software as a service. One more attractive thing about Google Cloud pricing is that it provides committed use discounts. For example, under this scheme, you can purchase a specific amount of virtual CPU cores and memory for up to 57% discount off regular prices if you commit usage for either 1 or 3 years. Now, this is just one option. There are various such options which you can learn about from the Google Cloud's page, and that really suits different customers for their different requirements. Now, when we talk about speed, we don't need to really challenge this aspect when it comes to Google services. So Google provides its Google Cloud and Google App customer speed up to 10 terabytes because of its faster cable system. There are different kind of machines which can be used if you're talking about computation, if you're talking about memory hungry applications, or even storage intensive workloads. All in all, Speed is one of the defining characteristics of Google Cloud Services. The cable has connections over US West Coast, main cities in Japan, and even major hubs in Asia. This speed enhances performances and leads to customer satisfaction. Now, when we talk about customers, any or every customer would prefer to have low latency, high throughput based services. They would want to use higher speeds to process their data in as less time as possible. Google provides a low latency network infrastructure. In fact, you can say that when you are using Google Cloud Services, you are using the services from the same infrastructure which Google uses for its popular services such as Google Search or even YouTube, which is one of the second largest repository which can be accessed for videos. Now, when we talk about big data is data which is very complex, has a lot of other characteristics such as your volume, you have velocity, you have variety, you have veracity, validity, volatility, virality, and so on. So if an organization is working on big data, Google Cloud can be a better choice because Google has many innovative tools for cloud warehousing, for example, such as BigQuery, and even real-time data processing tools such as Dataflow. BigQuery is a data warehouse that allows massive processing of data at high speeds, basically working on your structured data. Google also has launched some new machine learning from artificial intelligence tools. Now, there are various other services which we can use from Google Cloud Platform. But let's understand what is Google Cloud Platform and what are some of the services. Even the services which are not listed here can be found in your console from Google Cloud. So what is Google Cloud Platform? GCP. It is a set of cloud computing services provided by Google that runs on the same infrastructure, as I mentioned, that Google uses for its end user products like YouTube, Gmail, and even Google Search. The various set of services offered by Google Cloud Platform are, so you have services which are specific to computing requirements. And again, in computing, you have various different options available. You have machines which are compute optimized, machines which are memory optimized, machines which are storage optimized, and also we have certain machines such as preemptive, which basically means that you could get a machine to work on at a far lesser price than any other machine. But when we talk about preemptive, these are the machines which can be requested on demand and they can be taken back by Google at any time. You have networking related services, which can be very useful when you are setting up your applications or your services across globe. You also have different services which are specific to machine learning, and organizations which would be interested in working on machine learning or artificial intelligence would be really interested in using these services. There are also innovative solutions to work on big data and big data related technologies. Now, when we talk about Google Cloud Platform domains, so we can break down these services into specifics, such as you have compute. Now, the compute service allows for computing and hosting the cloud. Now, when you talk about computing, here there are different services such as App Engine, you have Compute Engine, you have Kubernetes, you have Cloud Functions, and Cloud Run. When you talk about storage and database, so the storage and database service allows application to store media files, backups, or other file-like objects. Now, various services under this are as follows. You have Cloud Storage, Cloud SQL, Cloud Bigtable for unstructured data. You have Cloud Spanner, Cloud Data Store, Persistent Disks, and Cloud Memory Store. When we talk about networking, the networking service allows us to load balance traffic across resources. Now, as I mentioned earlier, resources could be your different resources which you would be using from a cloud platform, such as your devices, your instances, memory optimized or CPU optimized instances or other resources, creating DNS records, and much more. So various services under this are VPC, that stands for Virtual Private Cloud. You have Cloud Load Balancing, Cloud Armor, Cloud CDN. You have Cloud Interconnect, DNS, and Network Service tiers. When we talk about the Big Data Service, this allows us to process and query big data in cloud. Now, various services under these are as follows. You have BigQuery, Cloud, Cloud Data Proc, Cloud Composer, Cloud Data Lab, Cloud Data Prep, Cloud PubSub, which is publish and subscribing system. You have Cloud Data Studio. Now, you also have the developer tools, and developer tools service includes tools related to development of an application. Now, various services under these are as follows. That is, you have Cloud SDK, Software Development Kit. You have Deployment Manager, Cloud Source Repositories, and Cloud Test Lab. When we talk about identity and security, which is one of the primary concerns for any organization or any user who would be interested in using a cloud platform, Google Cloud really has taken care of this. So when you talk about identity and security domain, this deals with security services. Now, various services here are Cloud Identity. You have Identity and Access Management, that is Cloud IAM. You have Identity Aware Proxies. You have Cloud Data Loss Prevention API, Security Key Enforcement, Key Management Service, and many more. You also have cloud services which are related to Internet of Things. So very much would be used by organizations who would be working on IoT devices or the data generated by these devices. So various services here are Cloud IoT Core. You have Edge TPU and Cloud IoT. Also, when we talk about Cloud AI, that is artificial intelligence, this comprises of services related to machine learning and much more. So you have Cloud Auto ML, Cloud TPU, Cloud Machine Learning Engine, Job Discovery, Dialogflow Enterprise, Natural Language Cloud, Text to Speech, and much more. If you would be interested in services related to API platform, then there are different services under this category or this domain. So you have Maps platform, you have APG API platform, monetization, developer portal, analytics, that is API analytics, APG Sense, cloud endpoints, and service infrastructure. So these are some of the listing of services under each cloud platform domain. Now let's look at Ferrero use case, and let's also understand what was done here. So Ferrero is one of the famous chocolate and ranks third among worldwide chocolate and confectionery producers. It was found in 1946 in Italy. I'm sure you would have seen the Ferrero chocolates when you would have gone out to buy some chocolates. So the challenges here was that Ferrero, as we know, is sold in every supermarket and is known for its quality. Once the business grew, some issues arose, right? And that's what happens when the business grows. You have issues popping up, which could be related to the volume of data, the speed with which the data is getting generated, the variety of data, and also looking at your platforms which support different dynamic applications or your scalability requirements, performance requirements, and so on. So it needed data storage, processing, and analysis system for a wide customer database. There was a huge gap between the company and the people who bought its goods because the company relied on data-given sales outlets. Now that's one of the challenge. Ferrero wanted to create a digital ecosystem where there was a point of contact with its customers and also a foundation for an innovative data-driven marketing strategy. What was the solution here? So one of the service of cloud platforms or Google Cloud Platform is BigQuery. And this was an answer to Ferrero's challenges since it was capable of hyper-fast and efficient data analysis as a solution. Now, as I mentioned, BigQuery is a data warehouse which allows you to store structured data. Now, this could directly be used as a service where you could store in any amount of data and you would not be paying for storage. So there are different pricing models, and for data up to 1 terabytes, you would not be charged anything. And if you would be accessing the data, that is reading the data or processing the data from BigQuery, that's where the pricing model kicks in. Now, using Google Cloud's BigQuery, business analysts of Ferrero were able to store and analyze massive data sets in a very reliable, fast, and affordable manner. Consumer behavior and sales pattern data reports were easy to build and automate. And the analysis also followed Ferrero to adopt advertising across various marketing channels to serve the customer needs in a better way. What was the result? They could divide their database into real-time, actionable consumer clusters to generate more accurate user profiles. Ferrero was also able to personalize its marketing strategies to match the user needs. Now, Google Cloud Platform completely tailored the website, mobile content, and advertising, and created a very cost-effective media buy strategy. Now, these were some basics on Google Cloud. Now, as I said, you can always find a lot of details about pricing, about services, and also all the services are accessible in your free trial account. Now, let me just walk you through here. So one is you could always find details on documentation on each of these services. So if I would click on getting started, you have quick start, which basically shows you short tutorials. You have trainings and you have also certifications. Now, if we click on quick start, now that takes me to this page, which shows me quick starts, or if you would want to understand about different projects, if you would want to look into the documentation of creating a Linux virtual machine or storing a file and sharing it, deploying a container, Docker container image, and so on. So you have a lot of quick starts here. You can also look at Cloud Minute. On the same page, on the right side, you have docs. And once you click on that, it takes you to these links. Now this shows you build solutions, which shows you top use cases, best practices, all the solutions. It's always good to learn from these use cases which are available. And here you have different featured products and all the different services which Google Cloud offers. Now you can click on featured products, and that basically shows you a list of these products. Now here we have all the solutions which you can look at: architecture, database, enterprise level, big data and analysis, gaming related, Internet of Things, and so on. Now if you go down here, it shows you featured products, and that shows you some of the important products such as Compute Engine, which is belonging to the compute domain. You have Cloud Run, you have Anthos, which is for migration and basically cloud adoption. When organizations would want to move from on-premise to cloud-based solutions, you have Vision AI, you have cloud storage. Now that basically allows you to store any kind of data, whether that's an object. So this is acting as an object storage. You have Cloud SQL, which is basically a ready-to-use service where you would be using MySQL, Postgres, or any other SQL Server database services. You have BigQuery, which is a data warehouse, which basically allows you to store your structured data. And then you have your AI and machine learning related products. So you have AutoML, Vision AI, Video AI, text to speech, speech to text, and so on. Now you also have different platform accelerators which can be used. And in any of these cases, for example, if I would click on Compute Engine, which is a featured product from Google Cloud, now that shows you basically your quick starts using your Linux machines, how-to guides, which tells you completely working on a VM instance or working on storage, working on persistent disks, and so on. And it shows you the documentation here. Now you also have products and pricing option, which you can see for GCP pricing. And you could straight away go to the pricing. You could be looking at solutions, which talks about infrastructure modernization. Now, this is something which organizations are interested in when they would want to move from their on-premise solution to your Google Cloud. Now here I can say, for example, I click on infrastructure modernization. You can always find some case studies. What are the different solutions we have here, right? When you talk about Google Cloud, so you can always click on see solutions, and you can look at VM migration or SAP Cloud, right? Why Google Cloud, what it can be used for, VMware as a service, or HPC, that is high performance computing. And about these services we will learn in detail later. Now I can go back on the same page where I was clicking on the services. So you have quick starts, you have how-to guides, you have deep understanding of different concepts, right? And here, if I click on all how-to guides, so that shows me what are the different ways in which you can work with compute engine and working with different instances. Although it's quite exhaustive content, but then if you follow steadily, then you can learn a lot about Google Cloud. Now here I can just go back. So this is just giving you some idea on the different products which are available from Google Cloud, looking into different sections, finding right documentation here, right? And you can always look into each one of these in detail for each product which Google Cloud offers. Now, if we scroll down, we could see all the options or all the domains which we see here, right? Let me just go back because we got into solutions. Now we have quick starts, right? And then you can basically scroll all the way down to look at Cloud SDK, which can be set up on your Windows machine, like I have set it up on my Windows machine. Plus, when you use Google Console, you have a GUI, which I'll show you in a couple of minutes, and also a Cloud Shell where you can use your command line options to work with Google Cloud Platform. You have Cloud Console, which is nothing but your GUI to access your resources. Now you can also look at in-depth tutorials, pricing, and you have different other options. So let's just click on pricing here. And then we have your price list, which basically gives you details of different services, what are available, and what are the services or what are the prices. So for example, if I click on compute engine, right, and this shows me the pricing aspect of compute engine, which belongs to compute domain. And here you can see you have VM instance pricing, you have networking pricing, sole tenant nodes, which are specific to particular organizations, or if organizations would want to have dedicated nodes, you have GPU based pricing, right? So general processing units, you have disk and image pricing, and you can click on any of the links and you can see pricing, which also shows you your different kind of machine types. So here you have different kind of machine types, which says N1, N2, N2D, E2. You have memory optimized machine types, you have compute optimized, you have premium images, and you can basically look at all the categories. You can look at disk pricing, which involves your persistent disk pricing for SSDs or HDDs. What are the kind of images, what are the different network services, right? And you can always look at your machine types. You can choose a particular region, right? There is the concept of region and availability zones here. And as per region, you could look at the prices. You can also look at standard prices. You could be looking for what are the free tier machines. If I'm specifically looking for VM instance pricing, I can click on this one. And that takes me to the VM instance pricing. What is the billing module? What is the instance uptime? What is the resource-based pricing? And then you can also look at different kind of discounts, such as sustained use discounts, committed use discounts, discounts for preemptible VM instances, and so on. And this is how you can be looking at pricing for all different resources. And you can choose the resource which you are interested in, and then look for the pricing, benchmarks, reservations if you would want to use and you would want to benefit, if you would want to look at what are the quotas and limits, and so on. So please explore this link and you can find a lot of information when it comes to technical options, looking at different Google Cloud products, which we briefly discussed when it comes to domains and what each product can be used for. You can always come back to the main page where I was showing you different services. We went into pricing straight away, right? Now you can always come back to this page on your cloud.google.com, and then you have your solutions, which talks about different products, right? And you can click on these, or you can look into technical documentation. So this talks about your different featured solutions, infrastructure solutions, you have data center migration related, and so on. So I could be talking more and more about Google Cloud Platform. It's a ocean. It's a huge chunk of different services for different organizational requirements. So look into this link. And also what you can do is create a account on Gmail. I mean, you could create a free account, or you could go to cloud.google.com and then you could create a free account like I have created here, and I can just click on console. Now that's my GUI, or Google Cloud Console, which basically allows me to work with Google Cloud. Now there are a lot of options here. By default, when you create an account, now in my case, on the top it says it's a free trial account. I have $300 credit, and out of that $251 is left, and 237 days out of a year are left for my account. Now here I can basically see the project, right? And by default we can create a project, or by default there is a project existing for any user. So when you log in, it creates a particular project, and you could create a new project, and project would be to dedicate your different services or different resources per different project. So this is your dashboard, which basically shows your project, which shows you a project number and a project ID, which is always unique. Now you can click on this, and this, if you would want, you can hide this information. You can also look into the documentation part of it. Then it shows you the different services, or a graphical information of services which you might have used in past. So you have Compute Engine, which shows you how much percentage of CPU was used. You can always go to Compute Engine as a service. You can look at your Google Cloud Platform status and look at the Google Cloud status. Now this is billing. Now since this shows me the billing period for April month, and I can always look at detailed charges. I can look at reporting. I can look at different APIs which Google offers. And for your different kind of work, you can always go to the API overview or the API link and enable or disable any API. Now, once you enable or disable any API, then you can use that. So you have news section, you have documentation, and you have getting started guides, which tells you how to work or enable different APIs. If you would want to deploy a pre-built solution, add dynamic logging, monitoring errors, deploying a Hello World app, and so on. Now this is your dashboard. I can click on activity, and that would show me what kind of activity I would have done in my cloud platform. I can always choose the kind of activities by saying activity type. I can choose the resources. Now it shows me that I created some VM instances, I deleted them, I updated some metadata, I basically worked on instances, I changed some firewall rules here. I have then also worked on some other services or APIs. So I created some buckets, which is for object storage. And again, I have been working with some instances and creating some firewall rules. Here, I have granted some permissions. I am setting up a policy, right? So this activity gives me a history of what things I have done over the past couple of months while working on Google Cloud Platform. Now, on the top left corner, you have the hamburger menu, which you can click on this. So that's your navigation menu. And when you click on this, this shows you home. It takes you to the marketplace. It specifically takes you to billing. You can always look at APIs and services. So here in API services, I can pretty much go to a dashboard and I can see a report on the traffic or errors or latency and the kind of APIs which are available. So you have Compute Engine API, you have BigQuery API, BigQuery Data Transfer API, BigQuery Storage, Cloud Data Proc. So these are some of the APIs or services I've used in past. Might be I was evaluating a product, might be I was using a particular product. So you have, whenever you would want to use a particular service from Google Cloud Platform, you would be enabling these APIs. So here we see some APIs for data proc. You have logging, monitoring, you have Resource Manager API, you have Cloud SQL, which allows you to directly use MySQL or Postgres, you have Cloud Storage, right? And so many APIs. So if I would want to enable a particular API, which is not right now required, but then it's good to know, you can always click on this one. You can search for an API. So for example, if I would say Dataproc, right? And that shows me the Cloud Dataproc API, which manages Hadoop-based clusters and jobs on Google Cloud Platform. So I can spin up a Hadoop cluster and I can start running some jobs on a Hadoop cluster on demand. And as I'm done with it, I can just get rid of it. So this is an API which I would have to enable. And then for every particular service, you also have an admin API, which you would enable. Now, going back, so coming out from this API library, I got into API and services. Now you can look into the library, you can look at credentials, and you can also look at different time intervals for which you can see the usage of your different APIs. Now, going back to the menu, you have support, wherein you can always reach out to the Google support team if you are using a paid version. Even with free trial, you can try to reach out and you will find someone to help, but it is always good when you have a billing cycle reaching out the customer care. You have identity access management and admin, and this is required when you're working with different APIs or services, when you would want to have relevant access. You have getting started, you have security related options, you have Anthos, which is mainly for migration. Now here you can look at your different domains, such as which we discussed. So you have compute, and in compute you have different services. So you have App Engine, you have Compute Engine, Kubernetes, you have Cloud Functions and Cloud Run. You can look into the storage aspect, which shows you Bigtable, which is usually and mainly for your unstructured data. Bigtable, which is something which gave rise to popular NoSQL databases like HBase and Cassandra. You have Data Store, which can be used. You have Firestore, File Store, Storage, which can be used to put in data of any kinds. You have SQL for structured data. You have Spanner as a service. You have Memory Store, and you have Data Transfer. Now, when it comes to the networking domain, you have all these services such as VPC, Virtual Private Network, network related services for your load balancing, for using a cloud-based DNS or cloud-defined network. You have hybrid connectivity, network service tiers, security, and intelligence. Then you have other options for your operations which can be used. And here you have different other tools which can be used, such as Cloud Build. You have Cloud Tasks, Container Registry, Deployment Manager, and many more. Big data specific, you have the services here. So you have Dataproc, which can be used to spin up your clusters. You have publish subscribe messaging systems such as now Kafka, which you might have heard of, originates its idea from here. So PubSub, you have Dataflow, you have IoT Core, BigQuery, which is a data warehouse package or data warehousing solution from Google Cloud. Now, then you have your artificial intelligence related services and other Google solutions. So you can always find a huge list of services, or you can say at high level solutions offered by Google Cloud. And we can use these to basically test some of the solutions, use them, and work on them. So I'll give you a quick demo on different services which can be used here from your Google Cloud Platform. Now this is your Google Cloud Platform and this is your console. Now this also gives you a Cloud Shell which can be activated so that you can work from command line, and you can always find a lot of documentation on that. So you can also set up your Cloud Shell, that is SDK, on your Windows machine, and if you have set it up, then basically you could be doing something like gcloud, right? If the cloud has been set up. So in my case, I had set up the Cloud SDK, and basically I can get into that by looking at what path I have set up. So Cloud SDK, and then I can be using it from my Windows machine as per my comfort. I can also activate the Cloud Shell here, which will basically open up a terminal, and at any point of time you can open up this one Cloud Shell in a different window. It is preparing the Cloud Shell, where it will by default set up your project. It will set up the metadata. And now I am logged into my Google Cloud account from command line. And here I can basically use gcloud, right? And that basically shows you the different options which are available, which you can be using. So if you would want to use a particular service, you can also try giving a help, and that shows you how do you manage your Google Cloud platform, right? So you have different options for billing, to work with your different services, and basically you could be working on Google Cloud using this Cloud Shell from your command line. Usually for people who are learning Google Cloud in the beginning, it is always good to go for console and use your different services from here in an easier way. But as I said, you can always use the command line. For example, if I would just go ahead and type gcloud create instances, and that will directly take me to the Cloud Console documentation, which shows you different options which you can use to work with instances. So I could do a gcloud compute instances create, and then I can give my instance name and so on. And I'll show you some examples on that. So you can be using your Cloud Console, right? That is your Cloud Shell, and you can straight away start working from command line. However, I would suggest using console in the beginning, and when you are well experienced, then you can start using Cloud Shell to do things from command line. And when you are fully experienced, you can always switch, and certain things are usually useful or easier when done from command line, and some are easier when you do it from the console. And you can use any one of these options. Now we can go to Google Cloud Console. Now, as of now, I can close this one. I still have my Cloud Shell open. If I would want to look into it, I can click on this one and I can straight away go to Compute Engine, where I would want to work on creating some instances on Google Cloud Platform using the Compute Engine service, and then basically connecting to those instances and basically trying out some basic things. So you can click on VM instances, and then once this comes up, I can always create some instances. Now, if you see here, I have some instances already created, right? And I can continue working on those. I can create new instances. I can use different options while creating instances, and I'll show you that in a demo in quick seconds. So let's have a quick demo on setting up GCP instances. Now, before that, let's have a quick recap. So when you talk about instance or a virtual machine, it is hosted on Google's infrastructure, right? And you can create your Google Cloud instance using this Google Cloud Console. That is by clicking on this and then going to Compute Engine and clicking on VM instances. Now, you can also do that from Google Cloud command line tool, that is Cloud Shell, and you can be doing that using Compute Engine API. So Compute Engine instances can run the public images for Linux or Windows servers that Google provides. You also have option of creating or using custom images that you can create and import from your existing systems. You can deploy Docker containers which are automatically launched on instance running containers, optimized OS. Now, when you talk about instances and projects, always remember that each instance belongs to a Google Cloud Console project, and a project can have one or more instances. When you talk about instances and storage options, each instance has a small boot persistent disk, which I will show you in further screens, that contains the OS. You can add more storage space if needed. And when you talk about instances and network, a project can have up to 5 VPC networks. So VPC network is virtual private networks, wherein you can virtual private cloud networks, where you can have your resources within your own subnet. And each instance belongs to one VPC network. Now, instances in same network can communicate with each other through local area network protocol. An instance uses internet to communicate within any machine. So that could be virtual, physical, or outside its own network. When you talk about instances and containers, you should remember that Compute Engine instances support a declarative method for launching your application using containers. Now you can create a VM instance or a VM instance template. You can provide a Docker image and launch the configuration. So there are different ways in which you can create these instances. And once you create these instances, you can say, for example, you're creating a Linux instance. You can associate SSH keys with your Google account or your G Suite account, and then manage your admin, non-admin access to the instance using IAM roles. If you connect to your instance using G-Cloud or SSH from console, which we will see later, Compute Engine can generate SSH keys for you and apply that to your Google Cloud or G Suite account. Now, what we can do is we can see how we can create your Google Cloud instances from your console or from the command line. Let's have a look in creating instances using GCP console. Now that we have learned on some basics of Google Cloud Platform, what are the different services, what are different domains, basically looking at your Google Cloud Console or even Cloud Shell, let's go ahead and create some VM instances. Now that's from your Compute Engine service, and let's try connecting to these instances and see how this works. Let's also see what are the different options which are available when you would want to create the virtual machine instances here. So when you click on your drop down from the top left and choose Compute Engine, so it brings you to this page. So I can show that again. So you can click on Compute Engine, click on VM instances, and that basically brings you to this page. Now here it tells you Compute Engine lets you use virtual machines that run on Google's infrastructure. So we can create micro VMs or large instances running different distributions of Linux or Windows using standard images, that is public images, and you can also have your own image. So let's create a VM instance by clicking on Create. Now that's basically helping me to create an instance here. So it shows me the instance name. I can give it something. So let me say C1. Now I can add labels. So what is label? It basically allows you to organize your project, add arbitrary labels as key value pairs to your resources. So this is basically categorizing your labels in projects if you have multiple projects. Now remember, if you have your Cloud Console and if you have created your free trial account, it will allow you to do these things. If not, you may have to go back to the billing section and see if the billing is enabled. Which also means that when you're creating your Google Cloud account, it will ask you to key in your credit card details, but they do not charge anything, or they might be $1 or 1 rupee depending on your location, and that's also refunded, but that's just to verify your card. Now, once I've given the name, I can choose a region. So I would basically choose Europe. Since I'm in Europe, I would be clicking on Europe West 3, and here I can choose an availability zone. Availability zone is basically to make your services or instances or any other resources highly available. So you can choose one of the availability zones. Now I would choose say West 3. Now this one, we can scroll down and here it says machine configurations. You have general purpose machines, you have memory optimized machines, which is M1 series, and you can always go back to the Google Cloud page and see what a particular kind of machine specializes in. So I would click on general purpose, and in general purpose you have different categories. So you have N1, which is powered by Intel Skylake CPU platform, or you have E2, which is CPU platform selection based on availability. So let's have N1 selected. Now this one shows me the machine type, and if you are using your free tier account, then you can start with correcting a micro machine, which is 1 virtual CPU core. You can go for a G1 small, which is 1 virtual CPU core and 1.7 GB RAM. You can even go up to a high-end machine, and then you can basically see if you're using a free account, how many of these machines you can use. If I would be selecting 8 virtual CPU cores and 32 GB of memory, then it would allow me to create at least 2 instances by this configuration. We will use N1 standard, which is 1 virtual CPU core, 3.75 GB memory. Now, then we can also deploy a container image to this VM instance. If you would be interested in deploying a container image, let's not get into that right now. Here it shows you the boot disk and it shows you Debian GNU 9 Linux 9. What I would do is I can go for this distribution, or I can choose a Linux distribution of my choice. So here you have public images, you have custom images, you also have snapshots if you have created backup of your previous images. Here I can choose, for example, Ubuntu, and then I can choose a particular version. So let's go for Ubuntu 18.04. You can go for the latest one also. 18.04 would be good enough. And here it tells me what is the boot disk. So you have SSDs, or you have standard persistent disks. Now SSDs are little expensive in comparison to your standard persistent disks or your SSDs, but then SSDs are faster. So as of now, we can choose standard persistent disk as it is, and we can let the gigabyte be 10. Now, depending on your requirement, you can increase this. You can even add disks later. That's not a problem. Click on select. Now here I have access scopes. So here I will say allow default access. You can also set access for each API, or you can give full access to all cloud APIs. So that, based on your requirement, you can anytime change later also. We will also say allow HTTP traffic, and we can also choose allow HTTPS traffic. That basically allows me to access this machine or services which are HTTP based accessible from this machine. Now I can just click on create. However, it would be good to basically enable connectivity to this machine. Now we can do that in different ways. One is when you bring up your machine, it will have an SSH access which you can log in from the cloud platform here itself. Or what you can do is you can create a private and a public key using some softwares like PuTTY or PuTTYGen. So for example, if you do not have that on your machine, you can just type in download PuTTY. That takes you to the putty.org page, and here you can click on download PuTTY and scroll down, which shows you for your 64-bit machine, which I have in my case. You can download putty.exe, which is basically your SSH and Telnet client to connect to your machines. You can also use PuTTYGen, which will be allowing you to create a private and a public key, which I have done in my case. Let me show you how. So what you can do is you can go to PuTTYGen to begin with, and here you can click on generate. Now then, to have this key generated, just move your cursor on the top here in the empty space, and that creates your key. You can give it a name. So for example, let's give a username. I would give HDU. Now I can give a password for this one. So let me give a simple password. And what I can also do is I can copy this public key from here, and for my later usage, I can just keep it in my notepad file, which I can use later, and I'll show you when. So now we can save this private key, and this will basically allow me to save my private key. I can choose desktop and I can give it a name. So let's say new key, and that will be getting saved in a .ppk file. So let's save it, and that's done. So we also have our public key and we have saved our private key. Now we know that when you would want to connect using SSH, you need your private keys to the client, and public key also has to be existing. So let's take this public key. So let's do a Control A. I'm going to copy this, and I'm going to come back to my Google Cloud Console, and here you can click on security. So you can click on the security tab here, scroll down, and just give your public key. Once you give that, it resolves and shows you the name, and this is good enough so that I can use my SSH client to connect to this machine. I can click on create, and this will basically create my VM instance. It will take some time, and then your instance will have an internal IP which will show up here, external IP, and it will also show you options to connect to these machines. So this is my internal IP, this is my external IP, which I can use to connect from a client. I can easily connect from the option here which says SSH, and I can say open in a browser window. I can even open this in a custom port. I can look at the gcloud command, which you can give from Cloud Shell, or you can use another SSH. So let's first do a open in browser window, and let's see if this connects. So we can easily connect to our instance the Ubuntu 18 instance, which I just set up here easily in a couple of seconds. Now this is trying to establish a connection using your SSH keys. And when you do that, it also basically brings up this web browser. So I'm already connected. It shows my username, which is my cloud account username. And I have been connected to this machine here using SSH. It did not ask me for any password. And basically now I can just check what do I have in my Linux file system, right? And I can anytime log in as root by doing a sudo su. For example, let's try installing a package, and I can say apt-get install vim, or apt-get install wget, or apt-get install open ssh, and all these packages are already existing, so not an issue. Now I can start using this instance. I can just look at the disk, what is available. Okay, now we gave around 10 gigabyte, out of which we see 8.3 gigabyte here for the dev SDA1, and then 1.8 gigabyte available. And you can continue using this machine. This was the easiest way of connecting to a VM instance using SSH. Now what we can also do is I can just leave this, and I will now try to connect using an external SSH client, right? And here you can copy the public IP. So when you want to connect to an instance, you will have to get the public IP. Also remember that if you select and stop this machine, which will stop your billing counter, and if you start it again, the internal IP will remain same, but the external IP is the one which will change. I can obviously select this machine anytime, and I can do a cleanup and I can delete it. I can do a start of the machine if it is stopped, and I can even import the virtual machine to be used later. So there are different options which you can always use. So this is my instance, and if you would want to look at the details, click on this one, C1, and that should basically allow you to look at the details. So it shows you what is the instance ID, what is the machine type, is it reservation specific, what is the CPU platform, what's the zone, and all the other details. At any point of time, if you would want to edit, you can always click on edit, and you can change the details as you need. Now you can also look at the equivalent REST command to basically use the REST API to connect to this instance. For now, I have copied the public IP, and I would want to connect it using PuTTY. So let's go in here, and let's give it the host name. So I can give Ubuntu, I can give my IP address. So that's in my session. Now I will click on SSH. I would go into authentication. I'll click on browse, and this is where I need to choose the PPK file. So this is the one which we created, new key. Let's select this, and then I can come back to session. I can even save this, and I can call it as my instance 1. Let's save it, and you can create any number of instances. So you see, I have created different instances here for my Google Cloud or Amazon related instances, and I can click on open. It says the server's host key is not cached in the registry. That's fine. Just click on yes. And basically it says no authentication method supported. Now this could be because we have not enabled your SSH access. So let's look at that. So now let's see if we were trying to connect using PuTTY, what was the issue here. So if I go back to my PuTTY, select my instance, load it, it says port 22. I'm giving the username, which is Ubuntu, or sorry, that's the wrong username we gave, and that might be the reason. We had set up the user as SDU. So let's save this again, and now let's try connecting to this one, and it asks for my password, and you are able to connect this. Right now, if there was any other issue related to network connectivity, then we could look at the rules, the inbound and outbound rules, which allow us to look into the machine. Now we are connected to our machine here using HDU user. I can log in as root, and I can continue working. So not only from the SSH within the Cloud Console, but you can use an external SSH client and connect to your machine. So this is your Ubuntu machine, and we can basically look at the space, and that basically confirms we are connecting to the same machine, which shows 8.3 gigabytes here and 1.8 gigabytes here, which we were seeing from the SSH in the browser. Now Let's close this and let's go back to our instance page. Now here you can always look at the network details, and this will show you your different kind of rules, that is ingress or egress rules, which basically allows to connect to this machine from an external network or for this machine to connect to an external network. So here we have different firewall rules, which shows default allow HTTP, that's your ingress rule, and it tells you apply to all. It shows me what are the IP ranges where I can specifically give the IP of my machine. It shows the protocols. It shows what are the different ports which you have used for these services. For example, RDP or SSH, which shows 22. You have ICMP, HTTP and HTTPS. Now, anytime if you would want to make a change to these rules, that can be done by going into your network details and say, for example, you would want to work on firewall rules. So we have these firewall rules here. You can click on this one. So right now we are looking into the network domain and we are looking into VPC network, right? And this shows me what are the different rules we have. Now, if I would want to create a different firewall rule for a different protocol, I can always click on create firewall rule. I can give it a name. Okay. I can say what if you would want to turn on the firewall logs. You can basically say what is the kind of traffic. So ingress applies to incoming traffic and egress applies to outgoing traffic. And you can then basically choose what are the IP ranges from where you want that connection to be coming in or to going out. You can choose a particular protocol. You can give a protocol here with comma separated values, and you can create a firewall rule. So this might be required depending on the services which you are running, wherein you might want to enable your access to your machine from an external service or to an external service. So you can always go to network details. From here you can then go into firewall rules, create a firewall rule, apply that to your instance and restart your instance. So as of now, we don't need to create any network details here because my ingress or egress rules are already available, right? Now I can basically then have my instance stopped and removed. So I can just do a stop, or since this is running, the ideal way would be to do a stop. I could also do a reset. Now what does reset do? Reset does not basically delete the machine. What it does is it does a cleanup of the machine and it brings it to the initial state. So sometimes we might have installed certain things on our machine. We would want to clean them up, and at that time reset can be useful. I can basically click on delete, right? And I can select this and I can do a cleanup. And this is good always when you're using a free trial account. Try to use different services, play around with them, and then you can clean up so that you do not waste your free billing credit, right? And you can use it for meaningful stuff. Now I have clicked on delete, and within a few seconds my instance which I had created will be deleted. Also to remember is if you are creating multiple instances, then you can connect from one machine to other machine using SSH by using the private file. So for that we can learn in detail later. So this is just a simple example of using your compute engine, creating your instances, connecting to it from an internal SSH or from an external SSH client such as PuTTY, where you have already created your private and public keys. Now I can click on the browser here, and then I can basically come out and I can basically be looking into any particular service. So we just looked into compute engine, right? You have different other options. You have instance groups, you have instance templates. For example, let's click on instance templates here, and that basically shows you that you don't have any instance template. And this basically facilitates, say for example you are working as an admin and you would want to create an instance template, so that using that you can describe a VM instance and then you can basically use this template to create different instances. You can go for sole tenant nodes, you can look for machine images, you can also look at your disks, you can create a snapshots, and you can look at different options here. Now let's come back here and let's click on home, and that should take you back to your home page, which basically shows you if a particular API which you have used recently, which shows me in the graph here. So I can go to the API's overview, right? And that basically shows me if there were any errors, if I was using the Compute Engine API to basically create a VM instance, and that's why we were seeing some spike in the graph. So this is a quick demo of using your Compute Engine service provided by Google Cloud, wherein you can create VM instances and use those VM instances for your application installation, for any other purpose. Now that we have seen how you use your Cloud Console to create an instance and also clean it up, let's also understand how you can do using your command line options, and let's see what it takes or what are the different commands which you can use to create your instances. Now you can always, when you're creating an instance, you can use Compute Engine, which provisions resources to start the instance. So instance basically has different states, which we can see when we are creating the instance. So you basically start the instance moves into staging, that is prepared for your first boot. Finally, it boots up and then it moves into running. So when you look at instance states, which we will create instance and see, it will basically have different states such as provisioning, where resources are being allocated for instance, but instance is not yet running. Then it goes into staging, where resources have been acquired and instance is being prepared for your first boot. Then instance is booting up and running, and if you are stopping an instance, it goes into being stop status and it would be moved to the terminated option. You can also do a repairing of instance, and finally you can terminate your instance or clean it up by stopping and then deleting it. Now, when you say stopping and resetting an instance, you can stop the instance as I showed earlier if you no longer need it. But if you need for future use, you can just use the reset option, which will basically wipe the contents of instance or any application state. And then finally, you can stop it and have it terminated. Now, when you would want to do that using your Cloud Console, we have seen the options. Now, let's also see from the command line tool how you can do it. So here I have the Cloud Shell, which I brought up from here, and I basically opened it in a new window. So command line tool enables you to easily manage your Compute Engine resources in a friendlier format than using your Compute Engine API. Now, gcloud, which is part of Cloud SDK, is the main command here, and then you can always autocomplete the different options here. So when you would want to create or work on gcloud, you can just type in gcloud here, and then, for example, I could just say help to see different options of gcloud, which will show me different options which you can use here. Now we would be interested in compute instances, so I could also do a gcloud compute instances, and then I can basically say create, and then I can do a help. Now that should show me different options which work with gcloud compute instances create command, which is expecting an instance name. So your Google Cloud SDK, which we can set up on our Windows machine or even on your Linux machine, is a set of tools that helps you to manage resources and applications hosted on your GCP, that is your Google Cloud Platform. Now here you have options such as gcloud, which I'm showing you right now. You have gsutil, and then you have bq. So that also can be used. So you can set up a Google Cloud Compute if using gcloud. Now what we can do is, if we are setting up our SDK on our Windows machine, then we would have to do a gcloud init, which basically initializes your configurations for gcloud. Now here we are using a Cloud Shell, which was started from the console, and we don't have to basically give your gcloud init command because it's already initialized. Now you can always look at your default zone, you can look at your region, what is being used. All those things are coming from the metadata which is being used. So for example, I could be looking at the metadata for my particular project by just doing a G cloud, and then I can say compute, and I would be interested in project info. So I can just do a project minus info, and then I can do a describe, and then I need my project ID, so I can say minus minus project, and I can get my project ID from here. So you can click on this one, and that's my project ID. So I can click on this one, and here I can just do a right click, and if it does not paste, then you can do a Control V, and then I can try to look at my project info. So this basically will give me the metadata, which is by default set, and we can always look at what are the regions or what is the zone which has been set. So if it has been set, so I'm looking at my details, it is showing me my SSH keys, and then it can be using your default region and your default available zones. It also shows my username and other details. So this is basically to look at the metadata which is available. Now at any point of time, I can basically say add metadata. I can basically choose metadata option, and I can say my default region should be Europe, which I was choosing earlier. So I can just bring up this command again. And what I can do is I can say here where I have G Cloud Compute project info, where I did a describe earlier. Now what I can also do is I can just say add metadata, and then I can specify what is the metadata I would be interested in adding. I can then say Google Compute default region, and then I can basically give a region, for example Europe, and then I can say West 3. And if you are not well experienced, you can always do it from console, or you can be doing it from here. So I'm giving Google Compute default region. Then I can also give a Google Compute default zone, and then I can pass in a value for default zone. So I can say Europe West 3, and then basically I can give an availability zone. So if it is basically giving me some error where I'm trying to pass in these values, so I can just give it this way, and then it basically says that if you can look into particular help to see what is the command which you would have to do. Now I can basically do a G cloud init here, initial configuration, and this basically says that it is initializing my default configuration. It says reinitialize this configuration from Cloud Shell. You want to create a new configuration. So if I had updated my metadata, then basically I could just do a cloud init, and I could be reinitializing my default configuration or properties which I have passed in. So as of now, I will not activate or change the default region. Let's go for a simple way in which you can create your compute engine. So for example, I'll just say 1, and it is reinitializing. It asks me what is the username, and let's select that. It says what is the project, and let's select that. And do you want to configure a default compute region and zone, right? And I will just say yes. And basically then it shows me different options which we have here. So there are too many options here. And then here we were interested in Europe West 3. So let's choose 21, right? And then that basically allows me to choose my region and my zone. So it also gives you some specifications. So it says your project default compute zone has been set to Europe West 3A. You can change it by running gcloud config set, and you can give a compute zone, right? So I can always give these commands. I can get help information here. So I can just say gcloud config set, and I can be specifying the compute zone. So I can say compute/zone, and I can give a zone. I can say compute/region, and I can give a region name if I would want to do it. Or the easier way is like what I did right now. So you can basically do a command gcloud init, and then basically it allows you to change your configuration or set default things here. You can all the times you can say gcloud config unset to basically remove a compute zone or a compute region. Now there are different ways. So if you were working on a Linux machine, you could always use an export command, something like this. So you could do a export cloud SDK, and then you can say compute underscore zone, and then give your zone name, or compute underscore region and give your region, or you could add it in your bash rc file. Right now, that is when you have your cloud SDK set up on your Linux machine or on Windows machine, and you would want to specifically set a zone and a region for all your compute related resources. So we don't need to do that. The default settings are already given here, right? And what we can do is we can start by quickly looking into gcloud compute instances options. So I can say gcloud compute instances, and then I can just do a list. At any point of time, if you would need help, you can just do a gcloud compute and then say minus minus help, or I could just do a gcloud compute, and that shows me different options which I have here, from which I use instances. I can always type instances and again hit enter, and it shows me different options what you would want to do. So I can initially just type list, which should show me what are the lists or what are the instances available. And as of now, we don't have any instances. I can always do a list, and then I can specify minus minus format, and then try to get the information in a JSON format or YAML or minus minus format text. So you can always do a list, you can do a filter. So there are different options with your list, and you can try doing a help here, and that basically shows you what are the options. So for example, if I do a help and it shows me with list what are the things you can do. So you can give a name, you can give a regular expression, you can say in particular zone, you can use a minus filter. So there are different commands which are available, and you can always find all those options here as I showed you earlier. So now what we would be interested in is basically going for your compute instances. I can always do a SSH, and I can create an instance. I can add and remove metadata, right, for my instances by giving a particular zone, by giving a particular region, and if you would want to do that. Now here what we can do is we can basically create an instance by just giving a name to that particular instance, and we can then go back to our console and see what has it done. So I can say here create, so that's an option. Let's see what does the create do. So it says, okay, you are giving a create option, but you would have to give a name. So let's say, let's call it E1, and that will be the name of my instance. And this one is an easy command from your Cloud Shell, which basically creates an instance. You see the zone which has been set. It is the standard machine type. It is not preemptible. It has an internal IP and it has an external IP. Now I have created an instance, and here I can just go back, and then I can just do a refresh on this page, and that already shows me the instance which I have created. And then you can use the same method to connect to it using an SSH. So I have an instance created from my Cloud Shell, and what I can do is I can basically look into instances and see what are the different options with instance. So if we did a create, right, you have an option delete. We did a create, you have an option delete. You can be then deleting the instance from the command line, or you can use other options. So you can do a list, you can do a stop, you can start. So I can basically do a stop, and let's say even let's go ahead and do a stop. Commands are pretty easy here to remember, or you can always use the help option. And now I'm trying to stop the instance, and then basically I can go ahead and delete it. So this is a simple way where I created a instance from the command line or from the console which I showed earlier. And similarly, you can be working with other options. So now I've created stop the instance. Let's do a listing to see if my instance shows up. It shows up, right? And it says the status is terminated. So you have stopped it. It's in the terminated status. And now what I can do is I can go ahead and delete it. So it says this will be lost. Are you sure you would want to continue? Just say yes, and that should take care of deleting your instance. So this is a quick demo on creating your instance. We have already seen how you can connect to these instances using SSH. Now that we have created instances, let's also see how to use Google Cloud's storage service, which can be used to load data or upload data. So for this, we will have to look into your Google Cloud storage options. And here you can look in cloud storage. So let's go back here on the top, which shows me different services which we have here. And let's look into storage. So this one shows me your storage option. Now you can click on browser, and that basically shows me your storage browser, which shows me on the top you have options for creating a bucket. Now Google Cloud Storage allows you to store any kind of data here. The easiest and the simplest way would be by using Cloud Console, although you can again use Cloud Shell, and in that you can use your gsutil command. And gsutil basically has different options where you can be using, say for example, I would want to work on buckets. So I can be using MB, and then I can use my command line option to create buckets. I can put in data there, I can browse it, and I can access the data from command line. So let's create a bucket here. Let's click on this. Let's give it a name. So let's say my data important. That's the name. Now I can click on continue straight away. I can look into all of these options if I'm interested in. So you can basically be looking at your monthly cost estimate in the beginning. Now I can click on continue, or you can say choose where to store your data. And this one shows you different options. So you have region specific. So let's also give the bucket name with all lowercase. That's what is required. Yeah. So coming back to the location type, you can choose multi-region, which basically allows high availability. So your bucket or your storage option will be accessible across regions. You can also give dual region and high availability and low latency across two regions. I can also say region specific. So for our use case, we can just give region specific, which can keep our cost low. But in business use cases, you would be going for multi-region. Now here you have location, and I would again go for say Europe, and let's choose Europe West 3 Frankfurt. It is always a good practice that when you create your instances, when you create your storage, or you use different services, try to have a geographical region chosen, and then you would try to put things or your services within the particular region, within a particular zone, unless you would want to make it accessible and available across regions. Now I can then choose a default storage class. So when you say default storage class, there are different storage class, and each one is for a different use case. So you have standard, which is best for short-term storage and frequently accessed data. You have nearline. So this is basically best for backups and data access less than once a month. You can also have cold line. So these are basically like your cold storage or freezing storage, which you might have heard generically as terms. So you can choose one of these storage classes depending on what will be the use case for this particular storage bucket. So let it be standard. Now how to control access to objects. So you can basically say specify access to individual objects by using object level permissions. Now you can give permissions to the bucket. You can just say uniform access to all objects in the bucket by using only bucket level permissions. So you can choose that. You can also go into advanced settings, and here you can see different ways in which you can have configuration set up. Now you can also have a retention policy to specify the minimum duration where that this bucket's object must be protected from deletion. and you can set a retention policy. We'll not get into all that. We will just first try creating a bucket. So just click on create, and that should create your bucket wherein I have my bucket. Now I can click on overview to see the details. What is the region, which region it belongs, what is the storage class. Anytime you can always click on edit bucket and make some changes here. You can look at the permissions. So bucket uses fine-grained access, allowing you to specify access to individual objects. And then you can basically look at who has access to this. So in my case, editors of the project, they basically are the bucket owners of project, viewers of the project, right? And you can basically choose what kind of access you need. So for this, you can always go into cloud storage, and then you can decide what kind of access you would want to give, whether that's a storage admin, it's an object admin, object creator, object viewer, and so on. You can always look at storage legacy, and for any other services, depending on what APIs you have enabled, right? You can always control your permissions. So right now it is storage legacy bucket reader, and that's fine. And this one is bucket owner. And then might be I was using some other services like data proc, which uses cloud storage. And that's why I've given data proc service agent also. So these are some of the members you can remove. You can view by specific members. You can view by roles. So what are the different roles which have access to this? So it says storage legacy bucket owner. There are 2 owners based on this particular project. So these are auto controlled, but then you can add or remove machines. You can save storage cost by adding a lifecycle rule to delete objects after the duration of current retention policy. So you can add different policies, and you can basically control your bucket. Now my bucket is already created, right? So I can go back, and then I see my bucket is already here. I can click on this option, and you can anytime edit the bucket permissions. You can edit the labels, the default storage class. You can just go ahead and delete the bucket. You can export it to Cloud Pub Sub. So basically, if you would want to have the content from this bucket being accessible in a message queuing system, you can go for Pub Sub. You can process with Cloud Functions, and you can scan with Cloud Data Loss Prevention. So there are different options which are available. We can always select this bucket and delete it. Now I can click on the bucket, and that basically shows me different ways in which I can upload some data here. So I can just click on upload files, and here then I can choose some files. So for example, I'll go in here, I'll go into data sets, and I have different data sets. So for example, let's choose this one, which is a CSV file. And then I'm just uploading this to my cloud storage, right? It's as simple as this. So you can drag and drop your files, or you can just upload your files, and my file is uploaded here. Now I can basically edit permissions for this one, right? So this is in the bucket. So anyone who has access to this bucket can basically download this file. They can copy, move, or rename this. You can export it, and you can look at the permissions of this file. So let's look at edit permissions, and it says for this project, whoever is the owner, it has access. I've also given a specific user, my Gmail ID, and I've given access. So at any point of time, you can just say add item, and then you can start giving different kind of accesses. So let's click on cancel here. Now my data is already uploaded into this particular bucket, and that's a simple usage of your cloud storage. Now what we can also do is I can basically select this, and I can delete it. I can also create specific folders and then basically load data into it. I can click on this one. I can just do a download, and then I can download it anywhere on my machine. So let's go to desktop, and let's download this file. So we not only uploaded some content in the bucket, but we also downloaded that in a different location, which will be accessible. Now what I could have also done is I could have created a folder here, and I could have specified, say for example, immediate data. Okay, and I'm clicking on this one. So that's my immediate data. I can click on this one, and now I can upload my data specifically to this particular folder. By using the same mechanism, you can just do upload file. Let's choose air passengers. Let's do a open and my file will be uploaded. So you can always choose what is the retention expiry date for this one. So as of now, there is nothing, right? But you can be deleted. Objects can be deleted or modified until they reach their minimum duration. You can control all of that. You can basically download it, right? You can copy it and you can move it and rename it. So this is a simple example where I created a particular bucket, right? Now, if for example, you click on this transfer, so it says cloud storage data transfer products have moved. You can now find storage transfer service, on-premise data and transfer appliance in new data transfer section, right? So you can always go back to cloud storage. You can also look at transfer options, which are mainly when you are using an on-premise service and you would want to upload data in a Google Cloud, right? So this is my bucket here. Now I can go to Cloud Console, and here what I can do is, if I would be interested in working, so I can just say gsutil, right? And then we have, for example, let's try a help, okay? And that basically shows me my gsutil. Now you can always go to quick start gsutil tool, and this is one more way wherein basically you can do it from the command line. So working with buckets, so you can do a gsutil mb -b and then on a particular zone if you would be interested in, and then you can say gs colon and give a name. So my awesome bucket, this is how you will create a bucket, which will show you it is creating a bucket. And then basically you can upload an image or some data from internet. You can just do a wget, download the file, and then you can just do a gsutil copy command, and that basically will pick up the file from your Cloud Shell location, put it in your bucket. Once you have done that, you can always do a copy, right? So here you are doing a copy from your local machine, that is your Cloud Shell machine, to your bucket, and you can do the reverse of that. That is, you can do a copy and you can point your bucket and the file and download it to your desktops. So you can just download that using the command line, and you can copy the object to a folder in the bucket. So that is by creating a particular folder and you're pushing the file into a particular bucket. You can list the contents of a bucket using ls and then give your bucket name. So gs colon. So we can just try this one to be simple, and rest you guys can try. So here you can just do a gsutil, you can do a ls gs colon / and then I need to give my bucket name. So in my case, the bucket name was my data important. So let's try that. So let's say my data important, and I'm trying to list the bucket and the content it has, right? And then you have a folder, and then you can look into the folder and look into the files. So this is a simple, quick option wherein you can use your Cloud Shell. You could be using your Google Cloud SDK from your local machine, or you can be using Cloud Console to create a bucket, upload some data on it, download the data, see if the data is accessible, and that basically shows you the power of cloud storage, where you can easily upload any kind of data. Now, what we can also do is, as you're using a free account or even a paid account, unless and until you would want to keep the bucket, you can select it and you can just go ahead and delete it. So this will basically ask you to key in the bucket name, and let's say my data important. You need to confirm your bucket name, click on confirm, and you could have done that using gsutil and a delete command from the command line, that is from Cloud Shell. So we have now created a bucket. We have uploaded some data into it. We saw how you can download it or create a folder and upload some specific data into it. And also you can do the same thing using gsutil tools, wherein you can list your bucket, create your buckets, delete it, create some folders into it, and do everything from the command line. So this is, in simple way, you can use your GCP, where either you can spin up your machines or you can use cloud storage to basically use a storage or a easy to use instance on Google Cloud Platform.
AWS versus Azure versus GCP. So let's get started. Amazon Web Services, or AWS, is a cloud computing platform that manages and maintains hardware and infrastructure, reducing the expense and complexity of purchasing and running resources on-site for businesses and individuals. These resources are available for free or for a fee per usage. Microsoft Azure is a cloud computing service that offers a collection of cloud computing services for building, testing, deploying, and managing applications in the cloud, including remotely hosted and managed versions of Microsoft technology. Google Cloud Platform offers a variety of cloud computing services for building, deploying, scaling, monitoring, and operating a cloud. The services are identical to those that power Google products, such as Google Search, Gmail, YouTube, and Google Drive. Now let's move on to the comparison between AWS, Azure, and GCP. We will be comparing them based on a few major parameters like origin, service integration, availability zone, cloud tools like compute, storage, networking, market share, pricing, and at last, who uses them. Now let's move ahead and start with the first comparison, origin. In the year 2006, Amazon Web Services, or AWS, was introduced to the market. And in the year 2010, Azure launched its services, whereas on the other hand, GCP was established in the year 2008. From the start, AWS has been supportive of the open source concept, but the open source community has a tense relationship with Azure. On the other hand, GCP, similar to AWS, provides Google Cloud with managed open source services that are tightly linked. AWS offers services on a large and complex scale that can be manipulated, but Azure's support is comparatively low quality, whereas GCP's monthly support price is almost $150 for the Silver class, which is the most basic of services and is quite expensive. Now let's move on to the service integration of these cloud platforms. Service integration is a set of tools and technology that connects different applications, systems, repositories, and data and process interchange in real time. AWS makes it simple for users to combine services such as Amazon EC2, Amazon S3, Beanstalk, and others. And on the other hand, Azure allows customers to effortlessly combine Azure VMS, Azure App Service, SQL, databases, and other services. Whereas users can utilize GCP to combine services such as compute, engine, cloud storage, and cloud SQL. Now that we know briefly about all these cloud platforms, let's have a look at the availability zones of these platforms. Because AWS was the first in the cloud domain, they have had more time to build and extend their network. But Azure and GCP both have various locations around the world. But the distinction is in the amount of availability zones they have. AWS now offers 66 availability zones, with an additional 12 on the pipeline. Close to it, Azure is available in 140 countries and is available in 54 regions throughout the world. But Google Cloud Platform is now available in 20 global areas, with 3 more on the way. Now let's move on to the next important factor, which is tools. Now let's move ahead and have a look at the first feature, which is compute. Elastic Compute Cloud, or EC2, is AWS's compute service, which offers a wide range of features, including a large number of instances, support for both Windows and Linux, high-performance computing, and more. Azure, on the other hand, as virtual machines, is Microsoft Azure's core cloud-based compute solution. It includes Linux, Windows Server, and other operating systems, as well as better security and Microsoft program integration. In comparison to its competitors, Google's computing services catalog is somewhat smaller. Compute Engine, that company's principal service, offers custom and predefined machine types, per-second invoicing, Linux, and Windows support, and carbon-neutral infrastructure that uses half the energy of traditional data centers. Within the compute category, Amazon's different container services are gaining prominence. It has Docker, Kubernetes, and it's also Fargate service, which automates server and cluster management when using containers, as well as other alternatives. Azure, unlike AWS, uses virtual machine scale sets of 2 container services. Azure Container Services is based on Kubernetes, and Container Service uses Docker, Hub, and Azure Container Registry for management. For enterprises interested in deploying containers, Google offers the Kubernetes engine. And it's also worth noting that Google was significantly involved in the Kubernetes project, providing an extensive knowledge in this field. Now let's move on to the next parameter of comparison, which is storage. Simple Storage Service for object storage, Elastic Block Storage for persistent block storage, and Elastic File System for file storage are among AWS's storage offerings. Block storage for REST-based object storage of unstructured data, queue storage for a large volume workload, file storage, and disk storage are among Microsoft Azure core storage services. GCP offers an increasing number of storage options. Its Unified Object Storage Service, Cloud Storage, also has a persistent disk option. Relational Database Service, or RDS, DynamoDB, NoSQL Database, Elastic In-Memory Data Store, Redshift Data Warehouse, Neptune Graph Database, and Database Migration Service are all SQL-compatible databases offered by Amazon. The database choices in Azure are specifically wide. SQL Database, MySQL Database, and PostgreSQL Database are the 3 SQL-based choices. Now, when it comes to databases, GCP offers the SQL-based Cloud SQL and Cloud Spanner, a relational database built for mission-critical workloads. Now, the next parameter is networking. AWS uses Amazon Virtual Private Cloud, or VPC. On the other hand, Azure uses Azure Virtual Network, or VNet. And GCP uses Cloud Virtual Network. Now let's move on to another factor, which is market share and pricing. All these cloud services are based on comparative pricing strategies, which means you need to pay on the basis of its usage. According to Canalys, the worldwide cloud market rose 35% to $41.8 billion in the first quarter of 2021. AWS accounts for 32% of the market, with Azure accounting for 19% and Google accounting for 7%. On one hand, Amazon charges on a yearly basis, and on the other hand, Microsoft Azure and Google services charge on a minute basis. And also, all of them provide you a standard price for you to access these services. AWS charges roughly $69 per month for a very basic instance with 2 virtual CPUs and 8 gigabytes of RAM. And AWS largest instance with 3.84 TB of RAM and 128 vCPUs will set you back roughly $3.97 per hour. But in Azure, the same type of instance, one with 2 vCPUs and 8 gigabytes of RAM, cost roughly $70 US per month. And Azure's largest instance has 3.89 TB of RAM and 128 virtual CPUs, and it costs about $6.79 per hour. Compared to AWS, GCP will supply you with the most basic instance, which includes 2 virtual CPUs and 8 gigabytes of RAM for 25% less. And as a result, it will set you back roughly $52 every month. And the largest instance that includes is 3.75 TB of RAM and 160 vCPUs, and it will cost you about $5.32 per hour. Amazon, other than this, also provides spot instances, reserved instances, and dedicated hosts where you can look for multiple offers and discounts. But for Azure, it provides special prices to developers based on situations, or even Azure Hybrid Benefit, which benefits your organization up to 40% if it uses Microsoft software in their data centers. Whereas Google offers quite assorted pricing to its customer compared to the other two. It gives you sustained use discounts, which activate if you use the same instance for a month. The printable instance, which is very similar to Amazon's spot instances, but one thing is common in all three cloud services, which is that they all offer long-term discounts. Now, let's have a look at the last comparison, which is the companies that are using them. Because AWS is the oldest player in the cloud business, it has the largest user base and community support. As a result, AWS has the largest number of high-profile and well-known clients, including Netflix, Airbnb, Unilever, BMW, Samsung, Misinga, and others. With time, Azure is getting a large number of high-profile customers. Azure currently boasts around 80% of Fortune 500 firms as customers. Johnson Controls, Polycom, Fujifilm, HP, Honeywell, Apple, and others are among its key clients. Google Cloud, on the other hand, uses the same infrastructure as Google Search and YouTube, and as a result, many high-end enterprises trust Google Cloud. HSBC, PayPal, 20th Century Fox, Bloomberg, Domino's, and other are among Google Cloud's many clients.
Now, cloud computing is one of those technologies that's rapidly rising, and with any technology that's growing rapidly, it comes with several job opportunities for the people who are skilled in it. So before we get into it, let's have a brief look at what is cloud computing. Cloud computing refers to services like storage, databases, software, analytics, machine learning, artificial intelligence, and so much more, all of which made accessible via the internet. The cloud tech services market is expected to grow 17.3% in the span of 2018 to 19, which means there's a growth from $175.8 billion to a whopping $206 billion in 2019. And as of 2020, it's expected that 90% of all organizations in the world would be using cloud services. Not to mention, several organizations around the world suggest that using cloud computing services has enabled their employees to experiment a lot more with technologies like machine learning and artificial intelligence. So here's what we'll be going through today. Firstly, we'll be talking about who is a cloud computing engineer, the steps you need to take to become a cloud computing engineer, and the cloud computing engineer salaries. So first off, who is a cloud computing engineer? Now, a cloud computing engineer is an IT professional who takes care of all the technical aspects of cloud computing. Now, be it design, planning, maintenance, and support. Now, a cloud computing engineer can take up a number of different career paths. This could be that of a cloud developer, security engineer, a full stack developer, SysOps administrator, solutions architect, cloud architect, and so much more. Now, let's have a look at some of the major cloud computing roles. First off, we have solutions architect. Now, these are individuals who are responsible for analyzing the technical environment in which they are going to produce the solutions, the requirements, and the specifications. Secondly, they are required to select an appropriate technology that satisfies said requirements. They need to estimate and manage the usage and the operational costs of the solutions they provide, and they need to support project management as well as solution development. Next, we have SysOps administrators. They are involved in deploying, managing, and operating highly scalable and fault-tolerant systems. They need to select an appropriate service based on compute, security, or data requirements. They need to estimate and manage usage and operational costs, and they need to be able to migrate on-premises workloads onto an appropriate cloud computing platform. So among both of these roles, there are certain requirements that are remaining constant. Now let's have a look at the steps you need to take to become a cloud computing engineer. Your first step is to gain proficiency in a cloud computing platform. Now the first step is to become proficient in at least one of the three major cloud computing platforms, be it AWS, Azure, or the Google Cloud Platform. platform. Now, there are a huge number of resources that you can find on the internet. It could be YouTube videos, articles, virtual or physical classrooms, and so much more. Now, after you're done learning, you can get certified by Microsoft Azure, AWS, or the Google Cloud Platform. Now, for AWS, you have a number of different certifications, which can be divided into 3 categories, which are the foundational, which is just the basics, the associate level certifications, the professional level certifications, and the specialty certifications. Similarly, with Microsoft Azure, you have certifications that enable you to become an Azure Developer Associate, an Azure Administrator Associate, an Azure Architect Professional, and a DevOps Engineer. Now, most cloud computing platforms have a free tier that you can take advantage of. These provide a number of free services for a period of time, some of which are free forever. So you can use these platforms to your advantage and do as much practice as you can on them. Now, if you want to learn more about cloud computing, you can also check out Simplilearn's YouTube channel. Then you can go on to the playlist section right here, and you can find comprehensive videos on a number of different cloud computing platforms, AWS and Microsoft Azure. Our AWS tutorial videos talk about what exactly is AWS, how you can become an AWS Solutions Architect, Amazon EC2, S3, some of the other services, and so much more. We also have detailed tutorials on Azure, which talks about what exactly is Azure, the certifications provided by Azure, some of the services like machine learning, Azure Active Directory, and so much more. And now we're at step 2, being experienced in at least one programming language. Unlike general purpose programming languages like C, C++, C#, and so on, cloud computing requires ones that are a lot more data oriented. Now, some of the major programming languages that are used in cloud computing are Go, Python, Clojure, and Java. Now, as I said before, there is a wealth of resources that you can learn from. There are free websites that you can practice your code on, like Quick Code, Code Academy, and several others. There's also resources like YouTube videos, as well as there's the option of online or offline classes. Now we're at step 3, specialization. You'll also need to be well versed with a number of key concepts. These are storage and networking. Now, with storage, you need to know how data can be stored and where it can be accessed from. You need to know how it can be accessed from multiple different resources. You'll also need to have some experience with the services provided by Azure and AWS, like the Amazon S3 in AWS and the appropriately named Azure Storage from Microsoft Azure. With networking, you need to have a strong understanding of the networking fundamentals as well as virtual networks. Next up, we have virtualization and operating systems. With virtualization, you need to know how virtual networks, which is just a combination of different virtual machines, can be used to emulate different components in a particular system. With operating systems, you need to have a very strong understanding of operating systems like Windows and Linux. Next up, we have security and disaster recovery. Now, you need to understand how data, application, as well as infrastructure can be protected from malicious attacks. With disaster recovery, you need to be prepared for any unexpected circumstance by making sure your systems are always safe and are regularly backed up to prevent any sort of loss of data. Then we have web services and DevOps. Now, you need to have a strong understanding of APIs or application program interfaces and web services. Some amount of experience with web design also can be of great help. With DevOps, you need to have a strong understanding of how cloud computing is able to provide a centralized platform on which you can perform testing, deployment, and production for DevOps automation. Moreover, with DevOps, you understand the synergy that the operations as well as the development teams have with each other and for the success of any project. And finally, you're a cloud computing engineer. Now, let's have a look at the salaries of cloud computing engineers. In the United States, cloud computing engineers earn around $116,000 per annum. In India, a cloud computing engineer is paid approximately 6,66,000 rupees per annum. Now,
we have reached the end of this cloud computing bootcamp. I hope this session was interesting and informative. If you have any questions regarding any topic discussed in the bootcamp, feel free to reach out to us. Our team of experts will be happy to help you out. Thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.